Suprabhat, my dear. Very good morning. So, very good morning to all of you. Hope you people are doing good. And especially the people from Odisha and West Bengal. So, you please be safe. So yesterday, I have seen some news regarding to this cyclone also. So you please be safe and your families. So if you're nearby any coastal areas, try to go into your any of your relatives' home, which is away from the coastal areas. That's better for all of you. Means all of the people who are staying there. And yeah, so I'll be discussing about the Bangalore issue also today, but not now. But yes, so I hope. Yes, now let's start our session, and meanwhile, we'll be discussing those things also. So don't worry about that. Yes, if you observe, yesterday I have been explained this Terzaghi's one-dimensional theory. So now, exam strategy, I have discussed the extra exam strategy already. Now you are asking again. You see, yesterday we discussed about the Terzaghi's one-dimensional consolidation theory, and there I said you Terzaghi gave the variation of excess pore water pressure with respect to time and with respect to the depth. So the variation with respect to depth of excess pore water pressure is known as isochrone, and by solving that condition, see, I have given you the pore pressure distributions for single and double drainage also. You please observe over here. So now Terzaghi explained variation. From this, we have one coefficient known as coefficient of consolidation, which is going to be Cv is equals to K by Mv into gamma W. And by solving, we got two solutions. One is time factor, which represents the time required for consolidation. Other one is degree of consolidation, which represents the percentage of consolidation. Or in other words, I said you percentage of excess of pore water pressure dissipated. So now, based upon this, one more equation is there, U is equals to S by SF into 100. And we got relations between the TV and U. When U less than or equals to 60%, TV equals to pi by 4 U square. U greater than 60%, TV is equals to 1.781 minus 0.933 into log base 100 minus U in terms of percentage. So theoretically, for complete consolidation, time is infinite. But for practically, if U greater than or equals to 90%, we assume it as a full consolidation. So now, what are the conditions I have explained over here? This is the very important. Cv depends upon soil, D depends upon dryness, TV depends upon U in terms of percentage. By keeping all the other constants, and if I change the dryness from single to double dryness, that means the time required for single drainage is going to be 4 times more than the double drainage. And similarly, if a building is constructed on a compressible soil, now with respect to time, it starts to settle down. What is the relation between the time and settlement? See, as we know, same soil mass, Cv is going to be constant, and same drainage condition, D constant. So this is the basic condition, TV directly proportional to T. And then I applied when you know that this TV depends upon you. And then I took an example. So this is an example I have been taken. So from this example, a building constructed. So from this, I got to know U1 comma U2 less than or equals to 60%. When U1 comma U2 less than or equals to 60%, directly I can apply T directly proportional to S square. Then if any one of the value is going to be more than 60, then you cannot use a T directly proportional to S square. Then you have to find out TV1 and TV2 separately. From relation TV directly proportional to T, you can find it out. See, the logics here are very simple, and then I have discussed you some previous GATE and IES questions. These are the previous GATE and IES questions. So today also we are going to discuss about some of the previous GATE and IES questions along with the classroom practice questions. Now let's start some of the classroom practice questions. For that, just give me a moment. Yes, now you see. So let's start solving some questions, please. Let's come to the question number 1 in the classroom practice questions. So this is the classroom practice question. Now let's come to the question number 1. So in the question number 1, you observe there is a question number 1. A 8-meter thick clay, layer is with a single drainage. So they have given the drainage as a single drainage, mind it. And so what is the thickness over here? 8 meters. So given thickness H is equals to 8 meters. So now as it is a single drainage, then what is the drainage path? Drainage path D is equals to H for single drainage. So for the single drainage path is equals to D is equals to H, which is nothing but 8 meters. Now settles by 120 mm in time 2 years. In time 2 years. And coefficient of consolidation is given as 6 into 10 to the power of minus 3 centimeters square per second. So coefficient of consolidation is going to be happen as 6 into 10 to the power of minus 3 centimeter cube per second. Yes. So now let's see how to solve this question. What is the question I am asking you at first? The ultimate consolidation settlement the ultimate consolidation settlement is a dash. So how much the ultimate consolidation is going to be half present. So at first SF. So now listen to me carefully, everybody. You know that SF means ultimate settlement. I explained you how to determine the SF by means of a MV equation. as SF is equals to MV into H into delta sigma dash. So you know the equations. SF is equals to MV into H into delta sigma dash. SF is equals to CC by 1 plus E naught into H into log base m sigma dash by sigma naught dash. So these are the primary equations we used SF. Yes or no? But my question is, now do I have any MV value? Do I have any CC value? No. So now what I do is, array sir, if there is nothing over here, then what I have to do? Now, first of all, you have to understand the question, how to approach. Okay, now if you see in the given question, there is a settlement and I want the ultimate settlement. What is the relation between the settlement and ultimate settlement? Degree of consolidation. So you know that U is equals to S by SF. So from this I can say, okay, if I know the U value, then I can say I can find out the SF. Yes or no? Yes. So if you know the degree of consolidation over here, degree of consolidation is nothing but S by SF into 100. So we can find out the degree of consolidation. Sir, how come I find out the degree of consolidation, sir? Sir, I told you TV depends upon U or not. Yes or no? There is a relation between TV and U. There is a relation between TV and U. So now what I do is, first of all, I'll find out TV. Once I know that TV, then I can find out U. Once I know the U means degree of consolidation, then I can find out S by SF. Then from there, I can find out the SF. So now let's see. How to find out the TV first of all. You know that TV is equals to CV into T by D square. We have CV with us, we have time T with us, and we have D with us. So now please substitute CV. 6 into 10 to the power of minus 3. This is centimeter square, right? Now multiply with 10 to the power of minus 4. That is going to be conversion of centimeter into meter. So centimeter square, 10 to the power of minus 4 meter square into, what is the time I have given? 2 years. Days, 365 days. Hours, 24 into 60 into 60. Because they mentioned in terms of seconds or not. So by what is the drainage path over here? 8 square. So TV is equals to 2 years, which means 365 days into 24 hours into 16 minutes into 60 seconds. So you please solve this one and let me know the value. 6 into 2 into 365 into 24 into 60 into 60 into 10 to the power of minus 7. By 64. So I hope you got a value of TV is equals to 0.591. I hope. So you got a value of TV is equals to 0.591. TV is equals to 0.591. So now the question is, listen to me. See, I hope up to this point everybody understood. Now, the question is, I need to find out TV is equals to CV, I need to find out the degree of consolidation. What is the relation between the degree of consolidation and TV? You see, when U less than or equals to 60%, TV is equals to pi by 4 U square. When U greater than 60%, TV is equals to 1.781 minus 0.933 log base 10 100 minus U in terms of percentage. Now the biggest question is, should I have to use this equation or should I have to use this equation? Do you know that degree of consolidation is going to be less than 60%? No. Do you know that degree of consolidation is more than 60% in this question? No. What I know is, I know TV. Now the question is, which equation I have to use? Should I have to go for pi by 4 u square, or should I have to go for the 1.781 minus log? So for that only I mentioned you please I hope you see these values. See, I hope you see these values. And yesterday I clearly said you, I will be saying you what is the importance of this value. You please look over this value, Nana. What is this value? Yet u is equals to 60%. What is the TV value? 0.286. Yet TV is equals to 60%. What is the TV at 60? 0.286. Arey Baba, if u is going to be more than 60, then time factor would be more than 0.286 or not? Obviously. I took u is equals to 60% as a reference. And from the reference, for u60, the TV is 0.286. So if I say the TV value is more than this, I can directly say u is more than 60. U is more than 60. So now let's go to the again. Now okay. See, as you know, yet u is equals to 60%, TV is equals to 0.286. So now the given TV, is more than 0.286. Then as TV is more than 0.286, then definitely U is going to be greater than 60%. So now I'm using this one. You observe over here. I'm using this one. At U is equal to 60%, TV is equal to 0.286. Now, from this, what I said is, as the TV is more than 0.286, U is going to be more than 60%. Then you know the equation is TV is equals to TV is equals to 1.781 minus 0.933 log base 10 100 minus U in terms of percentage. Okay. So now 0.591 is equals to 1.781 minus 0.933 log base 10 100 minus U in terms of percentage. Can you please find out U in terms of percentage here? 1.781 minus 0.591 by 0.933. So 10 to the power of 100 minus answer. So answer is going to be 81.14%. So now I hope everybody understood at this point. See, the point over here is, once I got the TV value, here the concept lies only at this point. You please observe that carefully. So here the question is like, if you observe here, once I find out the TV value, which equation I have to use? Pi by 4 u square or log? That depends upon TV value. And you know that at 60%, TV is going to be 0.286. I have explained this earlier also. Now, as a TV is more than 0.286, I can say U is going to be more than 60%. Once I know the U value, now you see Ultimate consolidation means 100% only, but finally, what is the settlement? You know that? Do you know the ultimate settlement? No. They have given some settlement. They have given some time, right? What is the meaning of some settlement in some time? So there is some consolidation happening. And what is the ultimate? That you need to find out the U value. So now, once I know the U value, now you see, observe. So I know the U value. U is nothing but S by SF into 100. So whatever the U value I got is 81.14 is equals to, yes, what is the settlement I have? 120 mm. 120 by SF into 100. So now can you please tell me what is the SF value? The SF value is going to be 147.89 mm. So if the soil undergoes complete settlement, it should be 147.89 mm. But what is the settlement they have given? 120 mm only. So now I hope you people understood how to determine the ultimate settlement using coefficient of consolidation and time factor TV and degree of consolidation. So now that's not the end of the problem. Now I am asking you one more question over here. The time to undergo 90% of consolidation in how many years? Now, everybody, can you please tell me the meaning of this problem over here? Okay, if you observe, what is the degree of consolidation here I got? 81.14 years. What is the meaning of degree of consolidation? 81.14% of excess pressure dissipated. And how much time it took? It took 2 years. With a settlement of how much? 120 mm. So see, this U value is for these details only, right? You please observe. For the TV, what is the time you used? 2 years. So at the end of that 2 years, what is the degree of consolidation? 81.14%. Now, if the time increases, then the degree of consolidation increases or not? Now my question is, if the degree of consolidation is 90%, what is the time required? So now, if you go for the so now we go for the 90%. Let's take the 90% degree of consolidation. Some of the students are asking, sir, why can't we go for U as 90% for the finding SF? Are Baba, if you go for 90%, did they mention the settlement for 90%? A given settlement is for 81.14%. So now, from data for U1 is equals to 81.14% or okay. In a time T1 2 years, the degree of consolidation is going to be 81.14%. Now, I am asking you, what is the time required for U to 90%? For U to 90%. So now, U1 and U2 has given as 81.14 and U2. So now there comes, whenever I ask your time relation, you know that U1 comma U2 both are greater than 60%. Yes or no? You know that TV is equals to CV into T by D square. Did I change any soil mass? No. CV is going to be constant. Did I change the drainage path? D is going to be constant. Then TV directly proportional to T. So I want T2 by T1 is equals to TV2 by TV1. So find out that TV1 and TV2. For this, what is TV1 please? Already we got the TV1 value. I hope you understood. See, what is the TV1 value here? 0.591. Already this value is 0.591. Now TV2 is equals to 1.781 minus 0.933 log base 10, 100 minus 90. 100 minus 90. Point 933, 1.781 minus answer. So 0.848. TV2 is equals to 0.848. So now from this, the T2 is equals to TV2 0.848 by TV1 0.591 into T1 2 years. So if you solve it, 2.87 years would be the answer. So that's the answer. Please have a look. Mr. Anonymous attendee, when ultimate consultation was given, why did you find U% it should be taken as 100%? Who said ultimate consolidation? That is ultimate consolidation settlement. You please look over the question, which means SF. Which means SF. What would be the final settlement they are asking? So that can be found out by using U. U is nothing but S by SF, right? You don't have to take anti-log. Anti-log, see 10 to the power, right? Log base 10x is nothing but, so you can take that 10 to the next power, 10 to the power of x, right? We know T directly proportional to U square. No, that's not going to be possible. You please go through the conditions once again. Whenever U1, U2 less than or equals to 60%, then only T directly proportional to S square. It's not going to be possible every time. Can't we use TV proportional to U square? How come you use TV proportional to U square? Are you seeing the yesterday's class? Have you gone through the yesterday's class? Mr. Sanket Jain, so I have not seen your mail. I'll be seeing the mail, so then I'll be replying you. So please say calculation of TV to find U% in calculator because of log. You can use log in the case of the virtual calculator. You please go through the YouTube videos. So there are a lot of videos are there. So I cannot say you how to use your virtual calculator also, because you can do that. What is the meaning of ultimate settlement? Ultimate means maximum settlement. At the end of the consolidation, what is the settlement? So I cannot find out directly. I cannot find out directly. So that is the reason why with whatever the known data, we are finding the ultimate settlement. Mr. Shivamanjit, why cannot we solve T2 by interpolation? How come you solve the T2 by interpolation, right? Do you have any mind? Have you been here in yesterday's class? If it is an interpolation, then why would I have been going through this entire topics? Think and say, what is meant by interpolation? What is meant by interpolation? Interpolation means if there is a direct proportionality directly, if 1 year 10 mm settlement, 2 years 20 mm, 3 years 30 mm, that is interpolation. But do you know exactly? See, I told you that yesterday's a shut concept. When you squeeze a shut, initially more water will come, which means in initial time settlement is more. And as you're squeezing, amount of water coming out is less and lesser and lesser, which means As the time increases, the rate of settlement decreases. It will never be linear. So you cannot use interpolation. Just don't apply your logics and say to me. I said you yesterday's class clearly. By using time factor general formula, we can find a T2. See, you can go for that also, but you need to find out, right? Yeah. So some of the person are saying, sir, you got the TV2, right? TV2 is equals to CV into T by D square. I can find out T2 there. But do you want to go for such a big calculation? Do you want to go for just this logic? You know TV1, you know T1. What you need to find out is TV2. Just you can find out this one, right? Okay, fine, fine, fine. Sir, U1, U2 both greater than 60, U1 or U2 greater than 60, then we should use, yes, the same, this relation. Mr. Amit, sir, for 81% degree of consolidation, settlement is 147. Who said, Ray, for 81.14 consolidation, the settlement is 120 mm. The settlement is 120 mm. What is mean by yes? Yes means a settlement at any time t. SF means a final settlement. I told you when time 0, settlement 0, degree of consolidation is going to be 0. When time t, settlement yes, u greater than 0. When time infinity, then yes becomes SF. See, when yes becomes SF, then only u will become the 100%. Yes. So if I give you 81.14, this SF is constant. Here this SF is constant. U directly proportional to yes. So this U depends upon the yes. For 81.14%, the given is 120 mm. So what we got is for 120 mm, 81.14% is there. Sir, in IAS, how to do such questions? In IAS, they won't give a step of questions. I'll be telling you. Already, I mentioned you in a previous IAS questions also. So don't worry about that. Sir, can we use trial and error basis to know if U less than 60 or greater than 60? Yes, you can go for the trial and error, Nikhil Megnani, but it is going to be long time taking. So I don't want to go for the trial and error. I know directly the given value is going to be more than 0.286. So if you remember this point, then you can directly say whether U greater than 60 or less than 60. So don't worry about that. Mr. Kaushika, but we are finding out the settlements beyond the ultimate settlement in the problem. Where, Ray? Where? Look over here. What is the settlement I have given? 120. Happening 2 years. And what is the degree of consolidation I got for the 2 years? 81.14%. Observe the question clearly. In a time 2 years, I undergo settlement of 120 mm, which is equivalent to 81.14 degree of consolidation. And what is the final settlement? 147. This is final. And where is the settlements? We are going beyond the final. No. Sir, I have done the interpolation. We got to 2.26. You get the 2.86. It's okay, now, sir. Yes, it's okay for you. You please keep the same answer in the examination. You will be out of coverage area. I said you interpolation techniques are going to be not working out over here. Yes. So that's all with these questions. I hope you understood. See, most of the people are. So there will be more settlement up to 100% consolidation. Yes, up to consolidation. What is the physical meaning of this 147.89 is, once the soil reaches 100% consolidation, you are going to get 147.89 mm. But what is the settlement we got? 120 mm. In what time? 2 years. And what is the degree of consolidation? 81.14%. So now I'm asking you one more point over here is a settlement. Yet 90% consolidation. So you please look over this one also. I'll be telling you. U is going to be S by SF into 100, right? So now I will take U2, S2. So can you please tell me what is S2 now? S2 is nothing but what is the SF? 147.89 into 0.9 means 90%. 147.89 into 0.9. So 133.10 mm. You see, for 90% consolidation, what is the settlement I got? 133.10. For 81.14 consolidation, what is the settlement? 120 mm. So the denominator is going to be constant over here. In the U value, the denominator SF is going to be constant. Now, let's come to the next question. This is question number 1, and the remaining questions we have solved already earlier. You please look over there. Now everybody, see question number 1 I have already solved. Then sir, why you use interpolation in previous lecture? I did not use any interpolation, my dear. You please go through that. Okay, fine. Now, you please look over the question number 2. See the question number 2. Already we have solved this question number 2 earlier. Now let's see the question number 3. See, in this question number 3, I am not going to solve, but I am going to leave you. A building constructed on a compressible layer settles 80 mm in 4 years. So 4 years may 80 mm settle. So I can take T1 as a 4 years. And settlement is going to be 80 mm. Now, assuming that degree of consolidation at both the times is less than 60%, what is the meaning of assuming that degree of consolidation at both the times less than 60%, which means U1 comma U2 less than or equals to 60%. When U1 comma U2 both are less than or equals to 60%, then what is the settlement in time T2 is equals to 9 years. So you know that whenever the U1 less than or U1 comma U2 less than or equals to 60%, I already told you, you observe over here itself there is a yes. So whenever there is a, you observe over here, they mentioned when U1 comma U2 less than or equals to 60%, of what I got to here is T directly proportional to S square. So I hope you understood this one. Now I can apply directly over here. So in this question, can I apply the condition directly? Yes. So given is T1 4 years, S1 80 mm, T2 9, then what is S2? As U1 comma U2 less than or equals to 60%, T directly proportional to S square. So I hope you can solve this question. For this one, it's not taking a small, means it won't be taking much time also. You can go through that. The answer is going to be like 120 mm. So you please go through that once again. Now, let's see the next question. Yeah. We have solved question number 4, and I'm giving you question number 5 as a homework for you. This question number 5 as a homework for you. Please, you go through the question number 5. I hope some of the people might have done that also. So if you have done, fine. If not, you go for question number 5 also. Now, let's see the next question. Question number 6 and 7. Question number 6 and 7. So now, please go through this point. So now, during a pressure increment, a test specimen during a pressure increment, which means increasing of the pressure, a test specimen 20 mm thick under double drainage attained 50% of primary consolidation in 45 minutes. So while we are conducting a test, the test is going to be consolidation test. I'm going to discuss after the problems. So listen to that. During a pressure increment, a test specimen 20 mm thick. See, this is a test. And what is the thickness of the test specimen? I am giving you as 20 mm. 20 mm. Under double drainage, right? What is the meaning of double drainage, Nana? Double drainage means drainage path is equals to H1 by 2 because of the double drainage. So given is double drainage. So H1 by 2 means 10 mm. And it is going to be attain a 50% consolidation in just 45 minutes in the laboratory. In the laboratory, by conducting the consolidation test, a soil specimen of thickness 20 mm provided with a double drainage. You know that in the case of double drainage, the time required is very less. So 1/4 compared to the single drainage. Yes. So 50% consolidation. What is the meaning of degree of consolidation 50%, right? 50% of excess pore water pressure dissipated, or 50% of total settlement has done. Not fully, 50% of total settlement has been done. So now this is the data. Now, how long will take a 10-meter thick clay layer of the same soil? What is the meaning of same soil? Same soil means it's a permeability same, compressibility same, which means a coefficient of consolidation is also going to be same. So now, how long will take 10-meter thick layer of the same soil in the field? In field, see, what is the meaning of 10-meter thick? See, it's going to be too large or not? Now, 10-meter thick, same degree of consolidation, which means U2 is going to be 50%, same degree of consolidation. If the clay layer was drained on both the surface, which means double drainage. So clay layer was drained on both the surfaces, which means double drainage. So again, this is also double drainage, which means 10 by 2. What is this value? 5 meters. So now, what is the time required? I hope everybody understood our point over here. So first of all, understand the question. If you can understand the question, then you can find out the answer also. So what is the data? They have given test. Conducted test on 20 mm. What is the drainage? Double drainage. And what is the time required? 45 minutes. And within a 50% of for 50% of consolidation. Now the same soil. Now I can say same soil. CV is going to be constant. Same soil, CV is going to be constant. Yes or no? When CV is going to be constant, again. Now, same degree of consolidation. Same degree of consolidation. Then TV is also going to be constant. because TV depends upon U. If U value U1 and U2 both are same, then TV is also going to be same. So you know the equation, TV is equals to CV into T by D square. Now, from this equation, TV constant and CV constant. Then what is the relation over here? T directly proportional to D square. T directly proportional to D square. Now, T2 by T1. 45 is equals to D2. What is D2? 5. See, I can write this one into, this is mmr not. 5 into 10 to the power of 3 mm. 5 into 10 to the power of 3 by 10 whole square. You please find out this T2 value. Into 45 minutes. So you will be getting some 11.25 into 10 to the power of 6 minutes. 11.25 into 10 to the power of 6 minutes. So 10 to the power of 6 minutes. Now convert that into years also. Convert that into years. See, for minute, right? By 60 into 24 into 365. So after all doing, then you are going to end up with 21.4 years. So now everybody understood. See, the same test specimen, but the thickness is how much? 20 mm. It took only 45 minutes. Now, my question for you. Yesterday onwards, our previous question. This is the previous question, right? Please listen. Please listen, everybody. See, they mentioned that the settlement undergoes 120 mm in 2 years. Yes. Do you think the person will be sit next to the building and wait for the next 2 years to determine 120 mm settlement? No. What we do is we take the small sample, we find out the test in the laboratory, and we get the details in the laboratory. This is the laboratory, right? This is the details from the laboratory. And from the laboratory, I got to know for 50% consolidation, 45 minutes. For 50% consolidation in the field, what is the time required? What is the time required? How much time is going to be required? 21.4 years. 21.4 years. Now, you see, there is one more thing next to here. So what is this value? 21.4 years. Now, if the clay is drained on the top surface only means a single drainage. See, earlier question is for the double drainage, right? And now they are asking for the single drainage, then the time required to reach the same degree of consolidation. So now, if clay is drained on top layer only, then it is going to be single drainage. So for same degree of consolidation, you know, time for the single drainage is equals to 4 times of the time for the double drainage. So what is the time we got in the double drainage over here? 21.4. So 21.4. 4 into 21.4, which is going to be 85.6 years. This is the time for the single drainage. So now, Okay, I hope you understood this. So now let's see. See, that's the end of this question. You please go through this once again. What I have done, simply, I know this equation, I am making something as constants. Yes. So now I'll be adding one more question in here. This is question number C. Time required for 80% of consolidation in field. Time required for 80% of consolidation in field. If clay layer is drained on both the surface. So come on. Now I am giving this question for you. You see, I have find out what is for 50% consolidation. You see, for 50% consolidation. So in the case of field, for 50% consolidation, I got to find out 21.4 years. Yes. Now I am asking you for the same degree of consolidation. Sorry, for same drainage, which means double drainage. I want to find out for 80% degree of consolidation. I'm giving you 1 minute of your time. Solve it and let me know in the comment section. I'll be waiting for you. I want answer. Miss Kajal or Vodka 0. If you keep that 0, you will also get 0 in the examination. Answer is 61.81 years. Answer is 61.81 years. You see, what I am asking you is, again, now, you please observe, from given data for U1 50%, what is the time required? We got 21.4 years, right? Now for U2 80%, what is the time required? See, you know that again, TV is equals to CV into T by D square. Every time I'm writing, same soil, same drainage, TV directly proportional to, when U1 is equals to 50%, TV1 is equals to pi by 4 into 0.5 square. Because U is less than 60% or not. So can you please tell me pi by 4 into 0.5 square, which is a 0.196. And U2 is 80%, then TV2 is equals to 1.781 minus 0.933 log base 10, 100 minus 80. So log 20 into 0.933, 1.781 minus answer. So this is going to be 0.567. So now, as you know, TV directly proportional to T, T2 by T1 is equals to TV2 by TV1. So from this, T2 is equals to TV2, 0.567 by 0.196 into T1. What is the T1 value? 21.4. So which is going to be 61.9 or 61.81 also, though that's fine. Yes. So nearest decimal is going to be somewhere 62 years. That's the answer. Yes. So I hope you understood the concept over here. I have introduced, see, this is a question in this, whatever the B, I have framed there. Here also I framed the same thing, 61.92 years. So you please go through this once again. See, understand the question carefully. The meaning of degree of consolidation means out of total, this much has happened. That's it. Mr. Harish, please tell me conversation of minutes to year. You please tell me, Baba. So divided by minutes, divided by 60 to hour, divided by 24 to day, divided by 365 to year. $61.02 years, will it be correct or not? You please check over whether whatever the values you got is same as in the board, then you can say. Sir, why can't you take U1 by U2 is equals to T1 by T2, sir, as U is directly proportional to TV, sir. Sir, if you want to apply, you please apply, sir. There is no relation like TV directly proportional to U, sir. Sir, if you see, sir, when U is less than 60%, sir, TV directly proportional to U square, sir, not U, sir. But when U greater than 60, sir, there is no direct proportionality because there is a log value. So if you want to use your own terms, then fine, you can use it. Sir, why can't we take 45 minutes of time, sir? You take, sir, because I am asking you in field, sir. Please listen to the question, sir. It is in field, sir. I'm not asking the laboratory. Sir, I got 61.81 years. Is it correct in exam, sir? Yes, it is correct. So don't worry, because while they give this type of questions, they will be giving you the range. So big range would be there. Some like a 61.7 to 61.62 years also. So now let's go to the next question. See, we have solved question number 6 and 7. Now let's go to the 8 and 9. So this is also a very good question that I want to say you. Sir, if we have CV value, then we solve directly. Yes, we can solve, but so please explain small conversations. Yes, I am explaining you. So I'm explaining you whatever I can do. How we get known settlement of structures in practically? In practically, you can see the ground means the structure is going to be settled slowly. That is not going to be happening within a day. Are Baba, you are observing, right? You please observe over here. Kitne saal the settlement is going in over here? 85.6 years. Can we live? Can we live for the next 85.6 years? You tell me, please. Can we live? No, we cannot live. So the settlement is not going to happen within a day or within a minute. The settlement in reality and practicality, it will happen over years and years of time. And what happens over the years and years of time is the ground level is going to be subsided. Now let's come to the question number 8 and 9. Stop. These type of questions asked in IES preliminary examination. See, for IES preliminary examinations, you please go through the question number 20, question number 2nd. Whatever the question number 2 is there, right? In the classroom practice question, I have given you question number 2. You please go through that question. Such type of questions will be asked for the IES. Mr. Kaushik, sir, at 100% consolidation, TV is equals to 0.4848. Are Baba, at 100% consolidation, what is log 100 minus 100? 0. Log 0 kya hai? Log 0 kya hai? Can you find out log 0? So now coming over here, so let's come to the common data for question number 8 and 9. How come we find time for ultimate settlement? This type of students, why you people are coming late? See, I have given you in the notes yesterday. I told you practically and theoretically for 100% consolidation, time is infinity. A building constructed on a compressible clay layer with a double drainage. Now you see, I have constructed a building. When I construct a building, you know that soil will not change. Drainage will not change. And it is going to be settled by how much? 80 mm in how many years? 4 years. So settlement S1 as 80 mm in time T1 as 4 years. The final settlement is expected to be about 300 mm. What is the meaning of final settlement? Ultimate. At the end, the ultimate settlement is expected as 300 mm. Okay. Now the settlement that would occur in 25 years. So what is the settlement that would occur in 25 years? See, does this example is going to be same as the previous example I have given you yesterday? But there I gave you settlements, I asked you time. But whatever it is, I don't care, because we know TV directly proportional to T. TV directly proportional to T. So now my question is, can I use a T directly proportional to S square? You know the T directly proportional to S square, right? Can I use this equation directly? When can I use this equation? When U1 and U2 less than 60%, then only you can use this one. Yes or no? See, how come I find out U1? What is U? S by SF. U1 means S1 by SF. I can find out because I have S1, I have SF. But what about U2? Do you know S2? No. When you don't know S2, you cannot find out U2. So we cannot use this relation blindly. Now, what I do is, I know that same soil, CV constant, should I have to write it again? No. So because I have taken a similar type of one, now you know that I want a TV2 by TV1 is equals to T2 by T1. And you know, TV depends upon the U in terms of percentage. Have a look over here. I have T2, I have T1. Now, I know S1, SF. Can't I find out U1? What is U1? S1 by SF into 100. What is S1? 80 by SF, 300 into 100. What is this value, please? 80 by 300 into 100, which means 26.67%. 26.67%. Now, once you know the U1, as this U1 is less than 60%, then TV1 is equals to pi by 4 into 0.267 whole square. Zero point 0.056. See, now everybody observe. I have T1 with me, I have T2 with me, and I have TV1. Can't I find out TV2 value? Yes. Find out TV2 by, what is the TV1 we got? 0.056. is equals to, what is the T2? 25 by 4. So find out the TV2 value. 25 by 4 into 0.056, which is going to be 0.35, which is going to be 0.35. See, normally what we do here is, now what we require is settlement, right? What we require is settlement. Yes, you please go to the question number 1. You please go to the question number 1. See here, I want the settlement, ultimate settlement, because they have given the settlement. For that, I need to find out UR. Now, once I got that TV value, what I know is for TV, there are two equations. Similarly, here also, I got the TV2 as 0.35. Now, what I required is settlement, right? In order to find out the S2, I need to find out U2. Yes or no? If I want to find out S2, I need to find out U2. And U2 depends upon whom? TV2. Now, which equation I have to use? Is it more than 0.286 or less than 0.286? This is more than 0.286. Then definitely U2 will be more than 60%. But you observe here in the given details. In the given details. If you observe carefully, they have given the details, right? This is one of the question. In this, I have mentioned clearly for 0.35, what is the degree of consolidation I am going to get? For 0.35, the degree of consolidation is going to be 65%. So I don't need to check over here. I don't need to check over here. So in this question, from the data, I can write, you see, for TV 0.35, what is U? 65%. So, and you know that U2 is nothing but S2 by SF into 100. Then what is the S2, sir? S2 is nothing but 0.65 into, what is the ultimate settlement given? 300 mm. So, which is going to be 0.65 into 300. The answer is going to be exactly 195 mm. So, you please go through this once again. What I have done is, I know the relation. I find out the TV value. See, just crisscross, Nana. Just crisscross means here as a. So whatever you apply to find out time, opposite is going to be settlement. Now, let's see the next question over here. The next question is, this time I'm asking you time. The time required to settle by 210 mm. You know it already. Array, just observe. In this question, 4 years, how much time, how much settlement? 80 mm. Now 25 years, how much settlement we got? 195 mm. 25 years, 195 mm. Now, what they're asking is for 210 mm. At 25 years, 195 mm. Then for 210 mm, definitely the time is going to be more than 25 or not? Yes or no? More than 25. See, I'm again explaining you. For 25 years of time, what is the settlement I got? 195 mm. Yes. Now, I want to find out the time for 210 mm. 195 mm occurs in 25 years. Then 210 mm will occur more than 25 or not? More than 25 means I can eliminate option A and option B. The answer will lies between 26.5 and 28.8. Now let's see. Given time T1, 4 years. Settlement was how much settlement I have given? 80 mm. Time T3, how much? When the settlement is going to be 210 mm. Sir, why you are taking T1, sir? Can I take T2? Yes, you can take. That's not a big deal. But you know there are some times, so I'll be taking. Sir, I can go for T2 also. You can take the T2, but you will be ending with the same answer. Don't worry about that. So don't ask me, sir, why you take T1 S1 only. I will be taking T2 S2 also. It's up to you. Now you know that SF is equals to 300 mm, and you know that U1. What is U1 value? What is U1 value? 26.67%. And for this, what is the TV1? TV1 I got as 0.056. And what is U2 value now? S2 by SF into 100. S2 by SF into 100, which means 210 by 300 into 100, which means this is going to be 70% or not? Yes. See, U1 is less than 60, U2 is more than 60. When U2 is more than 60, then you please find out. Now, again, from the data you observe, for U as a 70%, for U, sorry, U3 now, sorry. U3, S3. From data, for U3, 70%, then TV3, what is TV3? What is TV3 over here? The TV3, yes, 0.403. 0.403. That's it. Now you know TV directly proportional to T. Same condition. Condition is same everywhere. TV is directly proportional to T. So from this I want T3 by T1 is equals to TV3 by TV1. So T3 is equals to 0.403 by 0.056 into, what is the T1 value? 4 years. So you please find it out. 0.056 into 4. So the answer is going to be 28.78 years. So from the given options, 28.8 years. क्या रे भाई, इसके पहले वाले स्लाइड दिखा हुआ ना? हाँ दिखा ना रे, आओ मेरे घर को आओ, मेरे घर को आओ. I will show you the slide and I will show you front and back also. Come. क्या रे, आप कहाँ रे? I am telling you, see, if you are dare enough, you please keep your names. Don't send me a message like anonymous attendee. If you are dare enough, if you feel you are dare enough, then you change your name and you message. Then I will be knowing who are you exactly. Fall to it. Okay, it's fine. As some of the people are asking, sir, please do with the TV2, T2 also. Can I get the same answer or not? I think his name is anonymous. Yes, his name is anonymous, and his relation would be also anonymous only. Nobody knows what is his relation also. Now, I hope everybody understood. See, there is nothing to be confused over here. The only point is now you see, I'll be explaining in a. See, points to be remembered is points to be remembered. Number one, you have to check if it is the same soil. You know, CV is constant. Yes. And if it is the same drainage, means double drainage or single drainage, if the thickness is going to be same, D is constant. and same degree of consolidation, then TV is going to be constant. Now, for relation between time and settlement, time and settlement means T and S means time and settlement. Always TV directly proportional to T. Always TV directly proportional to T. And if U1 comma U2 less than or equals to 60%, then you can write directly T directly proportional to S square. Nothing there. So I am not saying anything beyond this point, right? That's it. You see any question I have done so far, you observe here what is the relation I take? TV directly proportional to T. And here also what is the relation I take? TV directly proportional to T. And then I am checking. I know times. And now I need to find out the S2. So how to find out S? You need to find out U. How to find out U? You need to find out T. Understood or not? So if they give settlements, listen. If they give settlements, you find out U, you find out TV, you find out time. Now opposite. If I give you time, you find out TV, you find out U, and then you find out the S. So just a reverse chronological order. That's it. Yes to time. If they give you settlements, you see this question. I gave you the settlements, right? What I have done? If I give you settlements, find out the degree of consolidations. Yes, I have done. Then find out the time factors. Yes, I have done. Then you find out the time. Understood? So I find out the time. And now, you see this question. In this question, what I have given, I give you times. And I want settlements. Now, if I give you times, you find out the time factors. In the C, you find out the time factor or not? Yes. You find out the time factor. Once you know time factor, you find out degree of consolidation, then you can find out the settlement. Not much formulas that you are remembering over here. The only formulas that you are remembering here is TV is equals to CV into T by D square, and when as U less than or equals to 60%, TV is equals to pi by 4 U square, U greater than 60%, TV is equals to 1.781 minus 0.933 log base 10, 100 minus U in terms of percentage. Now let's see the next one. I hope you people understood here. Mr. Srikanth, in first case, sir, I am rounded to 0.05. We are getting you 62. So no, you cannot round like that because there are lot means already the value is very less value, so you cannot round it like that. Sir, can't we use T proportional to S square, sir? See, I told you, Nana, whenever U less than or equals to, see, whenever U1 comma U2 less than or equals to 60%, then only T directly proportional to S square. You cannot use anywhere over here. You have to use when this condition occurs. If you need a proof, you please go through the yesterday's class. I have given you the proof also. Sir, if final settlement comes to some less years, then what kind of precautions we take on soils to minimize settlements? That we will be discussing ground modification techniques. So don't worry up to that point. Yes, in question number 9 now. In question number 9, T is directly proportional to S square. If you use this, I am getting same answer, but it is not applicable. Have you got the same answer? No, it's not going to be the same answer. You please try to check it once again. So if you look over here, no, it's not going to be same answer, my dear Kirtana. Here, the answer is going to be 27.56. Mind it, If you use wrong formula, don't think the values are going to be too much deviate. The values will be very less deviation. For example, if you use a t directly proportional to over here, see, if I use t directly proportional to s square for this condition, then I'll be getting the t3 value as 27 point something. But that's not a correct one. You have to know the procedure when to use t directly proportional to s square. So just don't use a t directly proportional to s square blindly. Please keep that in your mind. It's not same answer. It is 27 point something would be coming. It's not same answer. You please try it. Mr. Rushikesh also. So now, sir, how to know how many decimals we have to round off in the middle of calculations? Don't round off any calculations in the middle. Then when we use t direct proportional to s square, even though I got to know, even though I say 100 number of times, some people are don't want to listen what I say. They want to say what they want to say. That's it. You don't want to listen what I say. I'm not going to say it further also. So it's been a okay. Fine. Let's come to the next question, please. So this is also one of the question and very good question. These are different type of models. See, what I want you to from you here is today we are going to end up the consolidation chapter. Consolidation will be completed today. So I'm not going to take any doubt clearing session today. Why? Because I'm giving you time today. Today you completely study the chapter number 11. We took almost 4 days for this, which means more than 13 to 14 hours. Generally, I take so around 7 to 8 hours in offline class, but I have taken around 13 to 14 hours over here. So what you need to do is you please take all the PDFs of the previous class, means chapter number 11. You please go through each and every point. You please solve whatever the questions I have solved over here. And then if you have any doubts, I'm going to give a doubt clearing session tomorrow for 1 hour. I'm going to take 1 hour from 1 to 2 o'clock tomorrow. I'll be taking a doubt clearing session. So I'm not going to take any doubt clearing session today. Yes. Now the loading period of a building, you see, observe over here, this question, a small concept is locating over here. Once you know it, then the question is similar to the every other. The loading period for a building extended from 1957 February to 1959 February. First, what is the meaning of a loading period? I'm asking you. See, we know that when a structure is going to be constructed, do you think the structure can be constructed within a day? For example, you are planning to construct a home for yourself. So you are planning to construct a home. Now, when you are planning to construct a home, now the question for you is, are you going to construct your home within a day? No. You take some 6 months to 8 months, right? So throughout the 6 months to 8 months, gradually we are going to apply the load. Yes or no? How? First footings, and then basement, and then the ground floor, and then columns. Means ground floor means the plinth beams, columns, beams, slab, and then walls, everything. See, gradually we are going to apply the load, and that is going to be the loading period. Loading period means the time that you take to construct your whole structure. Now, the loading period for a building. So a building is started at February 1957 and it has been ended at 1959. In February 1962, the average measured settlement was 90 mm. So now you see, this is a load and sorry. This is time and this is load. It's starting Feb 1957 to 1959. This is the loading period, right? In the loading period time 0, 1957 load is 0. Now, by the time it reaches to the 1959, the load has been gradually increased or not. See, this is known as loading period. This is known as loading period. So now, once I know the entire loading period, you know that in this loading period, load is going to be increases gradually. Gradually means linearly. If I write suddenly, then that is going to be a curve. So now, and once I construct the structure at the end, from here onwards, the load is going to be constant, right? I hope you understood. So this is the end of the construction. And once you end the construction, the load is going to be maximum load as a constant. So now, in the question, I am mentioning you here as the average settlement 90 mm was measured at 1962. So S1 settlement was measured as 90 mm. And ultimate settlement is expected to be SF. What is ultimate settlement expected? 360 mm. So at the end, the ultimate settlement may be 360 mm. Now, estimate the settlement in February 1967. Now I want the settlement in 1967. Look, I want the settlement in 1967. For that, I required both the times, right? Now, see, I am making sure the data in the same previous classes. So whatever the data I write earlier, every time I write the data in this fashion. When I write the data in this fashion, then I would be knowing what to be calculated and what not to be calculated. So similarly here also I made now what is the new point I want to learn over here, sir? The new point that you are going to learn here is, when they give the loading period. So far I said you, see in this question, previous question, you please observe settlement in 4 years and I want settlement in 25 years. Yes or no? I gave you the time directly, 4 years, 15 years, 25 years or 20 years. But in this question, I did not give you time directly. I gave you in terms of years. Now, my question for you, do you think the settlement starts from 1957 only? Do you think, see, I have noted down the time at 1962, right? Do I have to take the time from 1957 to 1962? No. If you take, listen to that point carefully. If you take the time at 1957, is there any load acting on the soil? No load. When there is no load, do you think the settlement happens at 1957? No. So you are not allowed to take the time from the starting because here the load is less or no load. Now, can I take the time from the end of the building period? 1959? No. Why, sir? Again, if you see 1959, below 1959, some load was acting or not? Okay. So below 1959, some load was acting. Due to that load, soil will undergo some settlement. So while I was taking the time, I should not take at the starting point of loading period. I should not take at the ending point of loading period. Now, what I have to take is I should be taking the average time of the loading period. So now the note point is, if loading period is given, assume building starts to settle from average loading period. So now, what is the average over here? 1957 plus 59. This is going to be 1958. So now, from where I have to take the time? I have to take the time from 1958. So then what is the time T1? So soil start to building start is at 1958 and I measured at 1962. So 1962 minus 1958, which is going to be time as 4 years. And T2, what is T2 here, please? 1967 minus 1958, which is going to be 9 years, which is going to be 9 years. Now, I know the times. I want the settlement. Just now I said you, these are the points, right? Whenever a relation between time and settlement, you know that TV directly proportional to T. So I know the times and I want to find out the TVs. So now from this, what is U1? S1 by SF into 100, 90 by 360 into 100. Then U1 is equals to 25%. Then what is this is 25%. Then what is TV1? Pi by 4 into 0.25 square. So which is going to be 0.049. Now TV2 by TV1 is equals to T2 by TV1. So TV2 is equals to T2 how much? 9 by 4 into 0.049. So this value is going to be 0.11. Now again, everybody, again, I want whom? S2. For S2, I want whom? U2. In the previous question, they have given the data. From data, if U3 is going to be 70, TV3 is going to be, sorry, this value, okay, fine. From data, once I got the TV value over here, so I have used this value, but now I don't have any data, right? Now I can say, is it less than 0.286? Yes. When TV2 is less than 0.286, then U2 will be definitely less than 60%. So now you see as a U1 25%, which is less than 60%, and U2 less than 60%, U1 comma U2 less than 60%, then T directly proportional to S square. Now I can use T directly proportional to S square. So now we can go for the T directly proportional to S square. So I want a settlement S2. So yes, directly proportional to root 2, root T. S2 by S1 is equals to root of T2 by T1. S2 is equals to root of T2. T2 is equals to 9 by 4 into S1. What is S1? 90. So root of 3, 1.5 by 90 into 90, 135 mm. So the answer is going to be 135 mm. I hope you understood, because you see, observe, I got to know U2 is going to be less than 60%. This is the same procedure I was going from the starting onwards. In the previous question, I got U2 is 65% because TV2 is going to be given over there. Then I can find out S2. But now here, already I know TV2 is going to be less than 60%. Sorry, TV2 value is going to be less than TV 60%. So then I can use this relation, T directly proportional to S square. Then I can get down the value. S2 is going to be 135 mm. Please have a look. Now, extra. In the same question, I am giving you extra. I am giving extras for everything. Here, estimate the settlement in February 1967, right? Now I am asking you. Estimate settlement in Feb 1980. 1980. So you know that T1 is going to be 4 years. What is the settlement we got here? 90 mm. Now T3 1980 minus the loading period is going to be starts at 1958. So which is going to be 22 years. What is the S3 value? Again, you know, U1 is nothing but 25%. And TV1, what is the TV1 I have got? TV1 is going to be 0.049. 0.049. TV directly proportional to T. Then TV2 by TV1 is equals to T3 by T1. TV3 is equals to, what is the T3? 22 by 4 into 0.049. Which is going to be still 0.269. Which is going to be still 0.269. Now, this is 0.286, right? So what I do is, okay, fine, I'll be going for I'll change this. I'll go for 1985. Because I want to show you what happens when U2 greater than 60%. Now, Feb 1985. 1985 minus 1958, which is going to be 27 years, right? 27 by 4 into 0.049. So now you see, what is the value I got? 0.33. This TV3 is going to be 0.33, which is more than 0.287. So when it is more than 0.287, then you know that U3 is greater than 60%. And what is U1? 25%. What is U3? Greater than 60%. Now can you use this relation? T directly proportional to S square? No. You have to use then TV3 is equals to 1.781 minus 0.933. What is TV3 I have? TV3 is 0.33 into log base 10, 100 minus U3. Please find it out. 1.781 minus 0.33 by 0.933. Okay, 10 to the power of answer minus so now this U3 is equals to 64.09% and U3 is nothing but S3 by SF into 100. So what is S3? 0.6409 into what is SF I have given? What is the final settlement measure? 360 mm. Which is going to be 230.73 mm. So now you please observe, I have given you the details as are 4 years make kitne settlement? 90 mm settlement. And then now by that time you reach 9 years, then what is the settlement? 135 mm settlement. And by that time you reach 25 years, what is the settlement? 230.73 mm. I have given you every point over here. I explained you when U1 comma U2 less than 60% how to time. And I explained you when U3 is more than 60%, then you cannot use this relation, right? You cannot use this relation. See, because U1 is equals to 25%, which is less than 60%, and U3 more than 60%. So I cannot use T directly proportional to S square. So I have to go through this one, and I hope you people have understood clearly, because these are the conditions, very, very, very important. This is one of the gate comments classroom practice question that we'll be seeing at the end. So with this, we covered almost all the sorry sir, I don't have any intention by carry by. Okay, okay, fine. Sir, why should we do not calculate the years 1958, 1959, 1960? Here we get 5 years now. Nora Baba, you cannot take that. You cannot take like that. How to find out U3? See, Nana, this is log value, na? Log 10, right? So what you do is 0.33, 1.781 minus 0.33 and divided by 0.933. Then log base 10. Log base 10, if it goes the other side, 10 to the power of, okay? 10 powers. So that is log base 10, right? You take the other side, that's going to be 10 power. Then you can find out U3. Address. Okay, मेरा address Hyderabad है. So Hyderabad को आओ, मेरे को call करो. I mean, I'll give you my phone number also at the end of the class. So Hyderabad को आओ, मेरे को call करो. Then I can invite you to my home also, my dear. So some of the people is asking my address also. Fine, I'll be giving you all phone number. So note down the phone number 9999999999 up to 10 numbers. That is going to be 9. That's a special number, you know. So did anyone said you look like Rohit Sharma? Please answer that. No, nobody said that. Even I don't think I am. साथ में खाना खाएगा, ठीक है? But the treat is on you, not on me. Sir, how to take, when to take the average or not? See, that's what I mentioned. No? If loading period is given, assume building starts to settle from the average loading period. See, this is 1957 and 1959. The average is going to be 1958. For example, I would have given like 1957 to 1965. 1957 to 1965. What is the now? What is the value? The average is going to be 1957 to 1965. The average is going to be 1961. So you have to take 1961. Mind it. Okay, fine. Yes, my health is good now. Thank you for the concern. Yes, I'm there in a civil engineering Telegram group. I'm there. Okay, fine. Now let's go for the next things. Yes. So let's see some of the previous ES question. Yeah, the people, IAS people, I have given you some questions yesterday. Now, Excess pore pressure distributions within the thickness of soil sample tested in odometer. So anyways, I am going to discuss about the odometer as labeled something after loading as a 1, 2, 3, 4. Now, which one of these figures refers to a situation where the operator forgot to put on the porous stone at the top and the bottom? Porous stones are going to be provided for the drainage purpose. See, porous stones are provided for drainage purpose. So now, if porous stones are going to be, if porous stones are not placed, then no drainage. And when there is no drainage, no dissipation of excess pore water pressure. So far I was saying you above sand, below sand, above sand, below rock. In laboratory we have to provide a porous stone. I hope everybody have seen the porous stone. That porous stone permeability is more, so it will allow the water to come out easily. If you forget about keeping the porous stone, then the pore water will not dissipate. When the pore water will not dissipate, do you think this condition occurs? No. This condition? No. This is the condition. Answer is going to be 3 because no dissipation at all. See, I explained you yesterday or day before yesterday, I explained you clearly what happens if you provide a single drainage. What happens if you provide a double drainage? See this distribution, this is a pore pressure distribution at a time t for the double drainage, right? This is for double drainage. This is drainage at top and this is drainage at bottom. And what about this one, sir? This is no drainage. So if you have any doubt, you please go through the previous class. I'm going to show that also. So you please observe this. Yesterday only I have explained, right? Yes. So you please observe. For the double drainage, how the excess pore pressure distribution looks like. And for the single drainage, if I apply the drainage at the top, this is a single drainage. And if I go for the drainage at the bottom, then the figure is going to be reverse, right? So I hope you know that. Sir, I hate you. Yes, thank you, my dear. I love that the feeling that you hate me. So now let's go to the next rate of settlement. Now see this statement 1. Yes. Okay, before going to this, let's come to this question. This is also one of the previous IAS 2012 question. So consolidation time increases with increasing the compressibility. Consolidation time decreases with increasing the permeability. Consolidation time is dependent on the magnitude of the stress. You know that TV is equals to CV into T by D square. And from this I can write TV inversely proportional to CV. CV is equals to K by MV into gamma W. From this T inversely proportional to CV and inversely proportional to, so directly proportional to MV by K. So now you see, you observe consolidation time. The T represents the consolidation time increases with increasing the compressibility. T directly proportional to MV. So as the time increases, means as the compressibility increases, time is going to be increases, which means true. Now from this T inversely proportional to permeability, consolidation time decreases with increasing the permeability. The more the permeability, the less the time. So second option is also going to be true. And the consolidation time is dependent on the magnitude of the stress. The more the stress you apply, the lesser the time required. So time is dependent on magnitude of stress. So now all the three are going to be true. 1, 2, 3. So the answer is going to be A as 1, 2, 3. Answer A. So now okay, suddenly the screen went off. Okay, I have saved all these things. So am I audible to all of you? Am I audible? Yes. So now you see the next question. Yes. The rate of settlement. What is the meaning of rate? Rate means time. Rate of settlement means time. So settlement time of a consolidating layer depends upon its coefficient of consolidation. Yes. So rate of settlement means time. T depends upon the consolidation settlement function of yes. T inversely proportional to CV, which is directly proportional to the permeability and the number of paths available. You know that T directly proportional to D square. Yes. And this CV is going to be directly proportional to the permeability. See, observe here. What I want to mention over here is, if you see, rate of settlement of consolidated layer depends upon its coefficient of consolidation. And what is coefficient of consolidation? K by MV into gamma W, which is directly proportional to the permeability. So CV is going to be directly proportional to the permeability. And moreover that, and number of drainage paths available. See, you know that PV is equals to CV into T by D square. Then I can write CV is going to be directly proportional to D square also, right? So now the meaning of this one is rate of settlement time depends upon the quotient of consolidation. Yes, this is depends upon the quotient of consolidation, where this quotient of consolidation, which is directly proportional to permeability and the number of paths available. So statement number 1 is true. Second one, the excess hydrostatic pressure is relieved fast in soil of higher permeability. Yes, you know that the soils, whoever having high permeability, they will be having more time, they will be having less time to dissipate, because within no time they can dissipate. So the dissipation occurs so fast. In turn, depending upon the number of drainage paths available in the consolidating layer. What is the meaning of drainage path? Distance traveled or not. So if the number of drainages are going to be more, drainage path will be less. So the statement number 1 is true, and statement number 2 is also true, and statement number 2 is correct explanation for statement number 1. So now that's it. You have to look over the statements, whatever the terminology they are using. So that's it about the previous IAS questions. I have given you some questions which covers all the details regarding to this. Now coming to the previous gate questions. These are the previous gate, and you see this question, gate question, please. Yes. So now you see the E versus log P. This is log P and this is E. And I said you the convex upward curve is for whom? OCC. If you want to go for, you can go. This is for the OCC, and I'll show you also that one. If you look over here, yes, if you observe, this is a convex upward or not? Yes. In the case of the E versus log sigma, and if the curve is going to be convex upward, then it is going to be OCC. So answer is going to be over consolidated clay. Now I want you to understand this question, question number 2. This was just a previous question, GATE 2019 set 2. See, I am not discussing any GATE 2020 questions. I am going to take a time for GATE 2020 paper. At the end, once we complete all the chapters, I will be discussing you paper number 1, and means set 1 and set 2 of GATE 2020 at the end, so that you can analyze how you get the marks in the geotech in final examination. So I am keeping that GATE 2020 paper aside. So I am not discussing any GATE 2020 over here. I will be discussing up to GATE 2019. Now, construction of a new building founded on a clay soil was completed in the January 2010. So completed. It was a completed. So I don't need to worry about the loading period. And in January 2014, now the solution for this question. Now the solution for this question. So in January 2014, which means time T1, 2014 minus 2010. What is the time? 4 years of T1. The average consolidation settlement of the foundation in clay was recorded as a 10 mm. So by the end of the 4 years, the settlement was recorded as a 10 mm. The ultimate consolidation settlement was designated as SF 40 mm. And considering double drainage to occur at the clay layer, so the drainage is going to be double drainage. The expected consolidation settlement in January 2019. Now that T2 2019 minus 2010, it is going to be 9 years. What is the settlement? S2. Rounded off to nearest integer. They're asking rounded off to nearest integer, which means no decimals at all. I'm giving you 2 minutes of time. Please solve and let me know now. Come on, solve it. You know very well. They have given times. They have given settlement. You need to find out TV. From the TV, you need to find out U. You need to find out H2. Come on, solve it. After all the discussions I have given to you, you please, you need to solve this question. I will be knowing how many of you are able to solve this. Yes, the answer is 15 mm. Answer is 15 mm. So the people who have done that one, you have done very good, because these are the type of models. You see that GATE 2019 set 2 model, this was one of the question, right? What is there in this? Just simply, you first find out U1, please. You know that TV is going to be directly proportional to T. Yes. Now, what is U1? S1 by SF into 100, which is going to be 10 by 40 into 100, which is going to be 25%. Then TV1 is equals to pi by 4 into 0.25 square. Somewhere I have find it out. Somewhere I have find it out. Yes, 0.049. 0.049. And similarly, now you find out that TV2, please. TV2 by TV1 is equals to TV2 by TV1 is equals to T2 by T1. So what is TV2? TV2 is equals to 9 by 4 into 0.049. This is going to be 0.110, which is 0. less than 0.287. So U1 less than 60% and U2 also less than 60%. Because as it is less than 0.287, I can directly say U2 is also going to be less than 60%. Then I can write T directly proportional to S square, S directly proportional to root to T, S2 by S1 is equals to root of T2 by T1. Then S2 by 10 is equals to root of 9 by 4. Then S2 is equals to 15 mm. See, I have find out this TV2. I discussed this procedure so far. Today itself, based upon these values, I have given you n number of questions. So that's about this question. And this is also GATE 2018 set 2 question. And you know what, in 2018 set 1 also similar type of question has been given. The compression curve void ratio versus effective stress. The compression curve void ratio and effective stress in a semi-log plot as it passes. So they have given some compression curve in semi-log plot. You know that in the case of semi-log plot means log sigma dash and E, the curve is going to be a straight line, and you know it clearly. So now, so when some E is equals to 1.2, when some E is equals to 1.2, the sigma dash is 50 kilopascals. Now, when some E is equals to 0.6, let's take this E2, E1. Then what is a sigma 2 dash, which is going to be 800 kilopascals. Now, what they're asking is the compression index. You know the compression index is nothing but slope, right? You know the compression index is nothing but slope. What is CC? Delta E by log base 10, final here sigma 2 dash, initial sigma 1 dash. So what is delta E? 1.2 minus 0.6 by log base 10 sigma 2 dash, 800 by 50. So CC is equals to, please find out, 800 by 50, 80 by 4, 80 by 5 means 20, log 20, 1.2 minus 0.6 by log of 800 by 50. So 0.6 by answer, which is going to be 0.498, and now up to 2 decimals, right? Up to 2 decimals means 0.50. Answer is going to be 0.50. So up to 2 decimals. Sir, I didn't understand last question from GATE 2019. Right. What you did not understand, right? You please go through, Baba. Please, I have spent a lot of time for this question itself. So you please go through this. I have discussed a lot of questions based upon this one. As TV2 is less than 0.287, then U2 also less than 60%. Please go through all these things, then you can get that. This is a 2 marks question. What if you write 0.49? Then it will be gone out of coverage area. Okay. So that's all about the previous gate questions I want to discuss with you. There's one more question. Where is that? Yes. So we have completed all the questions. One question is left over. This question for this after the break, I'm going to discuss the details. Have a break now. It's 11:20 already. So after the break, we are going to discuss about the consolidation, means the test, a consolidation test known as odometer test. Also, we'll be discussing the test after the break, and then we'll be discussing about the immediate settlement. So we'll be completing the chapter. We'll be having a break, and after the break, we'll meet. The break timing is now it's 11:20. So have a break up to 11:35, 15 minutes. Now, okay, fine. So let's come to the whiteboard. So today we have not discussed much on the whiteboard. We were looking over the GATE questions and IES questions. So now let's come to consolidation test. Let's come to the consolidation test. See, this consolidation test we are going to conduct to determine the compressibility characteristics. To determine compressibility and consolidation characteristics. So what are the compressibility and consolidation characteristics, sir? What about the compressibility and consolidation characteristics are AV, quotient of compressibility, MV, quotient of volumetric compressibility, CC, compression index, CV, coefficient of consolidation. So this test is going to be suitable to determine this AV, MV, CC and CV. Now, the apparatus that we are going to use over here is consolidometer or odometer. Consolidometer or odometer. So that's the apparatus that we are going to use to determine the compressibility and consolidation characteristics. So now, for any test, we need to look over 4 points: aim, soil, apparatus, and procedure. Our aim is to determine these characteristics, and apparatus is consolidometer or odometer, and then soil. I told you clearly consolidation is suitable for who? Clays. And just recall over the points in the Terzaghi's one-dimensional theory. I hope you remember that Terzaghi's one-dimensional theory assumptions. Soil must be fully saturated. Soil must be fully saturated. Whiteboard is not working. What happened to whiteboard? Is it working or not? Can you tell me, is it working? Is it fine? Okay, fine. No, okay, fine. Yes. So now, consolidometer or odometer. This apparatus, see the basic assumptions for the consolidation is soil is fully saturated. So make sure throughout the test the soil is fully saturated. Make sure throughout the test the soil is going to be fully saturated. And number 2, always the dissipation should occur in vertical direction only. So on the lateral directions, you keep it as a rigid plates. You keep it as a rigid plates. So now what I'm going to do here is so these are 2 rigid plates. These are 2 rigid plates, and now these rigid plates, in between these rigid plates, we are going to keep the soil mass. Yes. See, whatever this is nothing but a soil mass. What I am writing over here, this is a soil mass, and these are rigid plates. These are the rigid plates, which means when I say rigid plate, now if you observe that as a disc, nana, that's as a disc. So in the sides, when you apply a rigid plate, do you think the water will dissipate in the lateral direction? You tell me. If there is a water, do you think the water will dissipate in the direction? No, it won't dissipate. Yes. So now these are the rigid plates that I have shown you. Yes. Now what we are going to do is this is a clay soil mass. Yes or no? You know that is going to be clay. And then we provide a porous stones at the bottom. We provide a porous stone at the bottom and the top. See, whatever this is nothing but these are porous stones. See, when I provide, see this entire soil mass, now this soil mass is fully saturated. You have to make sure the soil is going to be fully saturated. Whatever the plates I have provided over here, this is nothing but the porous plates or porous stone. So when the water is going to be dissipate, you see the dissipation of the water will occur in vertical direction only, not on the lateral direction. So that's the one of the assumption made by the Terzaghi. So what he said is dissipation should occur in vertical direction only, not on the lateral directions. So now, after all, this one, now generally the thickness of the soil sample we take it as, generally the thickness of the soil sample we take it as H is equals to 20 mm. We take the general thickness of the soil sample as 20 mm. So now, so whatever the device I have kept, this is known as a odometer. This entire device is known as odometer, and whatever this is nothing but the porous stones on the top and the bottom. There are porous stones. So which means you are going to apply which one? Double drainage. I hope you remembered one of the question. Field and lab. There I said you a test is conducted on 20 mm thick sample provided with a double drainage. Double drainage means above porous stone and below is a porous stone. So now let's see what we are going to do over here. So now my question for you. Are soil is fully saturated? Na? Do you think soil will undergo consolidation on its own or due to application of the stresses? It is going to be happen due to application of the stresses. Some of the persons were asking, sir, how consolidation time depends upon the stresses. You see, if you apply more stress, then due to that stress, more water will come out. That's what I said, a squeezing of fish, right? Remember that squeezing of fish? If you apply less squeezing, less water will come out. Then the time to come out the water will be more. If you apply more squeezing, then more water will come out. Then the time would be less. So the amount of the stress you applied and the time are dependent to each other. So the more the stress you apply, the less the time it requires. Now, what we are going to do is stress are applied in increments. Stresses are going to be applied in increments. For every 24 hours. So now what we are going to do is we are going to apply a stress, and for every 24 hours we are going to increase the stress, we are going to increase the stress. So how I am going to apply the stress, sir? Now you see, this is a stress. What I am going to apply is a stress, is a loading nana, and this is going to be a fill or load or stress. Let's say that stress is going to be Q. Let's say the stress is going to be Q. So now when you apply the stress, what happens, sir? After you apply the stress, due to stress, soil will undergo consolidation and attains full compression and attains almost full consolidation at the end of 24 hours. And you know that at end of consolidation, you know clearly at end of consolidation, applied stress will develop as effective stress. So you know this, I am not discussing anything new over here. So what I do is I applied some stress. Let's say I applied 50 kilopascals. Now, due to that 50 kilopascals, soil will undergo consolidation and attains almost full consolidation at the end of the 24 hours. And note down compression at the end of 24 hours. And note down thickness of soil. So we need to note down the thickness of the soil mass. So now at the end of the consolidation, the applied stress is going to be, at the end of the consolidation, the applied stress is going to be developed as a effective stress. So what we are going to tabulate over here is see, we are going to tabulate in a way, number one, whatever the load in terms of kilopascals, I'm going to apply whatever the load or stress in terms of kilopascals, and thickness of the soil, thickness of the sample. You see, initially before application of any load, what is the pressure? 0 kilopascals. Yes. So now you understand the things first, then you can ask me a questions later. So first you listen carefully. Now you see, whatever the load I have applied is going to be at first as a kilopascals, then the thickness of the sample. So what is the initial thickness of the sample? Let's take the initial thickness as a 20 mm because I have taken the 20 mm. Now I applied a stress of 50 kilopascals. I applied a stress of 50 kilopascals. So once I apply the stress of 50 kilopascals, due to this stress, soil will undergo consolidation and attains almost a full consolidation at the end of the 24 hours. And note down the thickness. Arey Baba, due to this 50, then the pore water will dissipate over here or not? Yes or no? The pore water will dissipate above and below. There is a small space between here. Now, when the pore water dissipates, the thickness is going to be decreases. What is the initial thickness I have taken? H. Now the thickness will be decreases to some portion Let's take that thickness as 19.4 mm. Sir, why you have taken 19.4 mm? It's up to you. But you know that initially the thickness is going to be decreases more. Yes or no? Now, after 24 hours, you apply 50 today, you come tomorrow, you note down the thickness. Now, stresses are applied in increments for every 24 hours or not? Today I apply load of how much? 50. Tomorrow you go to the same time, note down the thickness. Now you apply a stress of 100 kilopascals, which means twice, Now you find out the H2. Let's take the H2 you are going to get as 18.9 mm. And then you applied stress of 200. See, I am increasing the increments as a 2 times, and then 400, and then 800. So likewise, you apply a pressure of up to 800. Now, H3, let's take H3 is going to be 18.5 mm. H4 is going to be 18.2 mm. And H3 is going to be 18.1 mm. If you observe carefully, what I have done is over here. Observe, initially 20 to 19.4, which means thickness reduces by 0.6 mm. Then 19.4 to 18.9, 0.5 mm. 18.9 to 18.4, 0.4. 18.5 to 18.2, 0.3, and then 0.1. If you observe carefully, you know that during the consolidation, the compressibility of the soil mass decreases or not. Initially, soil undergoes more compression, and then later on the compression will be decreases. Once we reaches the 800 kilopascals, then I am going to remove the load. So now when I remove the load, see, when you remove the load, then what is initial thickness? 20. Now, due to this load, the thickness has been reduced to how much? 18.1. Now, when you remove the load, soil will undergo some swell or not. You just imagine, soil mass, apply the load. When you remove the load, it will undergo a little bit swelling. Then the thickness is going to be more than the initial, means more than this value, then the final value is going to be somewhere 18.6 mm. See, you observe, I will write this separately. .6 mm. See, I am taking these values. You see, first from H to H5, the thickness is going to be decreases due to the application of load. Now, when I remove the load, do you think soil will undergo to 20 mm? No, it won't regain to 20 mm. It will be ended with somewhere 18.6 mm. And at the end of the consolidation, whatever the applied stress will develop as a effective stress. So I have effective stress with me. Now, I want to find out AV, MV, CC, CV. For finding this MV, AV, CC, then you know how I have explained you AV, please. What is AV? What is AV? The AV means quotient of compressibility, right? How we got AV? By plotting the graph in terms of E versus sigma dash. I have sigma dash, but where is wide ratio? And how I got CC? E versus log sigma dash. Where is wide ratio? And MV is equals to AV by 1 plus E naught R naught. Where is wide ratio? Now, once we get these details, now we are going to find out the void ratio. Now we are going to find out the void ratio. So the points that you need to remember here is, so this is the points at the end of the consolidation. Applied stress would be developed as effective stress. Once entire pressure or stress is removed, soil will swell, and attains more, just simply soil will swell. That's it. Soil will swell, and you see the thickness is going to be 18.6 mm, not 20 mm. I started 20 mm, but once I ended 0, it is no more 20 mm. It is going to be 18.6 mm. Suddenly we cannot reduce the stress. I am just removing the load. When I remove the load, see the test details are there. Now I need to find out the void ratio. What is this void ratio? Initial void ratio, thickness E0. And I need to find out E1, E2, E3, E4, E5, and this is going to be E final. So now how to determine the void ratio? Let's see that. Sir, why you have specifically load means stop the load at 800 kilopascal, sir? Because for 20 mm thickness, it was observed by taking n number of experiments. It was observed by 800. The values are going to be sufficient, so we don't go beyond that. Now, once we know this, now how to determine these values? How to determine this void ratio? Determination of void ratio. See, this is in the case of the consolidation test only. How to determine this void ratio? How? We have two methods. Number one, height of solids method. Height of solids method. So now let's take the same sample. This is the sample I have taken R0. Okay. So let's see. This is the sample. So what is the thickness of the sample? Initially, let's take the thickness of the sample. You observe this initial thickness. Let's take it as a H. So, and whatever, this is nothing but the solids, and this is going to be voids which are filled with the water. Yes. Now let's take, this is a cross section area as E. Now this is the height of solids. This is the height of solids. So when stress is going to be 0, initially the thickness is going to be H. Yes or no? Now you apply, when you apply the stress, what happens over here? Please tell me now. So now this is due to whom? This is due to application of the stress. Due to application of the stress, now whatever these values, you observe, whatever this value, let's take it as a H1, but what about the solids? The solids are going to be same. This is HS and here it is going to be solids. And what about the cross section area? What about the cross section area? Area is also going to be same. See, I have represented all these things from the figure only. This is a soil element of thickness H, and as it is rigid, there is no lateral deformations because this is a rigid, right? It won't allow the soil to deform laterally. So the deformation will be occurred in a vertical direction only. Now In the vertical direction, let's take at load 0, the thickness is H, and at load 50, the thickness is going to be H1. And how to find out these void ratios and all those things are. Now, let's see how to determine the void ratio by means of the height of solids method. So, what is void ratio? What is void ratio? Volume of voids to volume of solids. Yes. Can I write this one as area into height of voids by area into height of solids? You see, area is going to be constant. Then what is a void ratio? Height of voids to height of solids. Now you listen over here. If I write this one as E naught, what is meant by E naught? Initial void ratio. Then what is the initial height of voids? Can I write total thickness H minus height of solids? H minus height of solids by HS. H minus height of solids by HS. I hope you understood how I have written this one. I just simply wrote the height of the solids and height minus height of solids. Similarly, see, for H, this is E naught. Now, if I write E1, for E1, what is the height? H1. E1 is H1 minus HS by HS. Then what about E2? H2 minus HS by HS. So likewise, you see, in all these conditions, the common thing is going to be whom? HS, HS, and HS. We already know H, H1, H2. From the details, H is there, H1 is there, H2 is there, H3 is there, H4 is there, and H5 is there. We know all the thicknesses, but we don't know the height of solids. So if I can find out the height of solids, then I can find out the void ratios. If I can find out the height of solids, then I can find out the void ratios. So now, the height of the void ratios. How to determine the height of solids, sir? Now, from G, what is G? Gamma S by gamma W. What is gamma S? Weight of solids by volume of solids into gamma W. Now, can I write weight of solids by, what is the volume of solids? You please tell me here. What is the volume of solids over here? Area into HS into gamma W. Area into HS into gamma W. From this, can I write HS is equals to WS by G into gamma W into A. This is how you are going to determine the HS, where A is area of consolidometer. A is area of the consolidometer, because see, this is nothing but the cross-section area or not, because I took the soil sample in whom? Consolidometer. And WS is dry weight of clay soil. Sir, once entire pressure or stress is removed, soil will swell, and note down dry weight of soil and water content as WF by oven drying. See, once the entire pressure or stress is going to be removed, soil will undergo some swell or not, but you know that soil will be fully saturated. So now what I do is I note down the weight as a W saturated at the final, and I keep it in a oven dry. Once I own dry, entire water will evaporate. I find out the dry weight. Once you know the final weight and once you know the saturated weight, then you can find out the final water content. So this is going to be done at the final stage, not on the initial stage. I hope you understood. Now that's it to determine the void ratio. These are the points that you need to know in this topic. So the questions that you can expect from the consolidation test are very less, but the points I need to say to you are these ones. So once we know this one, then height of solids are going to be the dry weight WS by G, specific gravity of the clay. You can do it by means of pycnometer and you can find it out. Gamma W, and A is the area of the consolidometer. So from this, I can find out the height of solids. Once I know the height of solids means, so then you can find out the void ratios. This is not E0, this is E0. E0 means initial void ratio. Similarly, there is one more method. The method name itself is a void ratio method. After knowing final water content, WF. Now you know SEVA, E into SR is equals to W into G. If I write as final void ratio and this is going to be final water content, you know that soil will be fully saturated throughout the test. Soil will be fully saturated throughout the state. At the end also, once you remove the stress, the soil is fully saturated or not? Yes or no? Yes. Then you can find out final void ratio as final water content into specific gravity. Now what to do, sir? So now what to do here is, after all this, some people are asking what is AV? What is AV? Quotient of compressibility. Okay, fine. Now how to determine the remaining void ratio? See, if you observe clearly, in the case of the height of solids, first I find out E0, then I went further. But in the case of void ratio method, I will find out EF. How, sir? You know the relation delta H by H is equals to delta E by 1 plus E. Yes. Now I'll write HF and I'll write EF. So now you see this delta H is equals to delta E by 1 plus EF. We know these values of HF and we know the value of EF. And now for E0, then delta H is equals to H minus HF and delta E is equals to E0 minus EF. So now please substitute over here. H minus HF by HF is equals to E0 minus EF by 1 plus EF. So everybody, you please look over here. What are the known things we have? You please look. Do I have H? Yes. Do I have HF? Yes. Do I know EF? Yes. Because I have find out the EF or not. So I know EF, I know HF, I know H, and I know EF. What is the only unknown here? E0. Then you can find out the E0. So you are going to find out after knowing the final water content. What is the meaning of final water content, sir? Once the test is done, sir, you take out the clay sample, sir, throw it in a oven dry, sir. Then from the oven drying, can't you find out the water content? Is it a final water content or initial water content? That is the final water content. So likewise, similarly, for E1, how much? For E1 also similar. Delta H means H1 minus final by final is equals to E1 minus E final by 1 plus E final. So here I am finding the final first, and then finding the void ratios. I know E naught. Now from here, I can find out the E1 from here. So now let's go back. You know E naught, you know E1, E2, E3, E4, E5, E6, and E7. This is how we are going to find out the void ratios by using either height of solids method or void ratio method. So once we know this, see from the table we obtained, this is a table or not? From the table, if we draw from the table, if we draw the variation of sigma dash in log scale with void ratio, normal scale with void ratio. You know the values, right? You know all the values are. So now if you go for that, then by drawing these figures, if it is a normal scale, then this is going to be a curve. Then what is the slope of this curve? The slope is going to be AV, and if it is a log scale, then the slope is going to be a straight line. Then this value is going to be CC. And once you know AV, then MV is equals to AV by 1 plus E naught. Then MV is equals to AV by 1 plus E naught. I hope you understood these values. So now, what about the remaining over here is, you see AV completed, MV completed, CC completed. Then what about CV, sir? Note, to determine CV, time fitting methods are used. Sir, what are these time fitting methods, sir? Number one is square root time fitting method. Number two, logarithmic time fitting method. See, I'm not going to be discuss these two because this is not going to be asked in the examination. So far in the GATE and IES, they have not asked any question regarding to these methods. So just you need to know the names of the methods, not the procedures. So forget about those remaining things. You just to determine the CV, we are going to use these fitting methods. That's it. That's it. Don't go into what are the fitting methods. I can say, but it's a time waste. It's a waste of our time only. So you don't need to worry about the square root time fitting method and logarithmic time fitting method. These are not useful for the GATE and IAS examination. You just need to know the names. That's it. So this is what the consolidation test. Please go through the consolidation test once again. I'm giving you 2 minutes of time. You please have a look. So do we take undisturbed soil sample or remolded one, sir? We have to take it as undisturbed because so while you are preparing, once you fill the soil, you need to little bit tamp it so that the disturbance that created during excavation will gone. After the test completed, there is no much amount of water. There is no much amount of water, but there is some water or not? No, don't means even though there is no much amount of water, there is some much amount of water would be there. Forget we have to know these things. Yes. Arey Baba, this is not a formula at all. See, I have discussed this condition somewhere in the starting chapters. I discussed this. Don't think these are formulas. In final water content determination, how the soil is fully saturated. Sir, you please go through the previous class, sir. I told you throughout the degree of consolidation, degree of saturation is 100%. Throughout the consolidation, degree of saturation is 100%. Due to compaction, little or very less water gets removed. No, compaction means expulsion of air only. The best faculty, I saw till date, none of the previous faculty cared about students. Thank you, Nikhil. That means a lot to me. My dear students, are discuss about Bangalore issue. No, I cannot discuss now because the things are going on in the Bangalore. So right now the investigations are going on in the Bangalore. I hope everybody have listened some news regarding to the Bangalore. There was a huge sound that has been listened by the Bangaloreans in the past 2 days. So there were a lot of conflicts going on. What is that sound? I am doing my own bit of research, but I'll be letting you know once. See, the final conclusions are not came yet. So I'll be discussing about the Bangalore situation tomorrow or once I get the entire details. Without knowing much details, I cannot see you all those things. Kaushik, there is no usual test value in the graph. It depends on the soil to soil. Yes, a lot of people are saying like, see, some of the theories says that it was a Indian Airways flight. So there was a one flight, IAF flight, and some were saying like supersonic sound, and some were saying like aliens were there. So these are only conspiracy theories. There is no truth, but I'll be telling you that once I know. Okay, fine. Now the last slide. You please go through this one once. Sir, you said that you will discuss about how to overcome anxiety during exam yesterday, but due to less time, you didn't say anything. Mr. Anonymous attendee, this is what the meaning of anxiety. This is what the meaning of the anxiety. You asked the same question yesterday and you asked the same question today. I saw these questions, but I just kept myself calm because that's meaning of anxiety. The first step to stop your anxiety is just make sure wait. Waiting is the first solution for reducing your anxiety. As long as if you don't wait for the other persons to say, your anxious levels are going to be increases. So for everything, if you want to take one step or if you want to go for one decision, you need to think, and during the thinking your anxiety process will decrease. So that's the reason why I did not say that. So flat ring is nothing but this porous stone. This porous stone, whatever the porous stone, we are going to call it as a flat ring, single drainage and double drainage. Okay, fine. Now I hope you have gone through this entire details. Now the last topic in this chapter. Contact pressure distribution. And settlement. Okay, fine. Before going to that, I will discuss one thing, because once I discuss that, then I can go for that. Immediate settlement. Immediate settlement. Yes, I. So what is this immediate settlement, sir? Immediate settlement means, you see, now everybody have a look. What I told you earlier is, when you apply the load, immediately water will take the pressure and slowly water starts to dissipate. Yes or no? When the water starts to dissipate, then such a consolidation is known as a primary consolidation. So far, whatever the settlement I have given you is a primary consolidation settlement. But if there is any air present in the soil, then immediately once you apply the load, air will escape out or not? Yes or no? So such a compression or settlement is known as immediate settlement. After application of load, after application of load and before dissipation of pore water, some compression will occur in clayey soils due to elastic nature. See, so far I have discussed about the primary consolidation or not. What is meant by primary consolidation? The reduction in volume due to expulsion of water. Now I am saying you, after the application of load and before the pore water is going to be dissipated. Just imagine, you applied a load, immediately some compression would be there, but still no dissipation. And that small compression is due to elastic nature of the soil mass. Such a compression is known as immediate settlement. What do you call? Immediate settlement. So now, if this is the footing, you see, if I apply a load of Q, then the pressure transferred through the base of footing, let's take that pressure Q as a capital Q by, you know that, capital Q by area of the footing. Yes. Okay. Now you see this soil mass, whatever the soil mass below over here, whatever the soil mass below over here. So now if you observe this soil mass, yes, this soil mass will undergo some compression. Now you see this soil mass will undergo some compression, and this compression is known as immediate settlement. See, you observe over here, actually there is no change in the volume. But what happens over here is there is a compression in the vertical direction and there is some extension in the lateral direction, so that the volume change is going to be zero. So after application of load, before dissipation of pore water, some compression will occur in clay soil due to elastic nature known as immediate settlement. Immediate settlement. So now if it is a partially saturated soil, air will escape. If it is a partially saturated, air will escape. And if it is a fully saturated, just there is a small extra compression, but no dissipation. That's the reason why after application of load, before dissipation of water, if it is air, air will escape, and that compression is going to be elastic compression. If you remember the initial compression or consolidation, I said you there, the compression is known as an elastic settlement. The immediate settlement is due to elastic nature. You can call this immediate settlement as elastic settlement also. This is going to be elastic settlement also. Whereas a primary settlement or primary consolidation is a plastic settlement. Now, how to determine these values, sir? So that immediate settlement SI is equals to Q by E into B into 1 minus mu square into I. Q by E into B into 1 minus mu square into I. Sir, what is this Q, sir? Q is pressure due to external loads. Pressure due to external loads. And B is small dimension of footing. See, why I take the small dimension of footing is, see, if it is a square, width and length both are same. But if it is a rectangle, you can ask me, sir, in the case of the rectangle, what I have to take, sir? Smallest dimension. So which is nothing but generally width. Generally width. So now mu is a Poisson's ratio. Mu is the Poisson's ratio. You see, what is meant by Poisson's ratio? Lateral strain by longitudinal strain. This is the lateral direction strain and this is the longitudinal direction strain. So lateral by longitudinal gives the Poisson's ratio, and whereas E is Young's modulus of soil. The E is going to be Young's modulus of the soil. Okay. So this is going to be the immediate settlement Q and B and mu and I. See, these are going to be elastic constants. That is the reason why we call it as a elastic settlement or immediate settlement. Then what about I, sir? I is influence value which depends on type of footing, which depends on type of footing. Influence value which depends upon the type of footing and L by B ratio. L by B ratio. See, they will give you the L by B ratio, and that depends upon the type of footing. Some people, Arey Baba, don't you have any patience over here? Why small dimensions, sir? Ye kya hai, sir? Then it's like, sir, why gate examination is only for the 100 marks? Why can't it be 150 marks? Sir, why in the gate examination they are providing for the technical as 70 marks? Why can't 100 marks? Why geotech has 20 subjects? Why can't geotech has 30 subjects? Why you have only 100 years of life? Why can't 1,000 years of life? Is it necessary for you? Yes, sir. Okay, fine, sir. Somebody is saying it is necessary for you. Then you please tell me what is your lifetime. I'll ask you some questions regarding to you. Then I can answer you also. Yes, sir. There is some e-value for the soil also. I will tell you later while I was discussing the question. I will tell you the later. So to wait for that, please focus on what I'm going to say. What is important, I will say you. So don't worry about that. So now you please look over. So in this case, see, this is a L by B ratio, L by B ratio 1, 1.5, 2, and so on. L by B ratio would be there. For the L by B ratio, I discussed about the type of footing. So if it is a flexible footing, I value will be somewhere like this. And if it is a rigid footing, I value will be somewhere like this. See, that data will be provided for you. You don't worry about that. That L by B ratio would be there. And 1.52 for flexible footing, there is a one value. For rigid footing, one value. So the I value of rigid footing is equals to 0.8 times of the I value of the flexible footing. Sir, what is this rigid footing and what is this flexible footing, sir? So there I am going to discuss about the contact pressure distributions. So first of all, what are the examples of the rigid footing and the flexible footing, sir? Flexible footings, which is nothing but like a bituminous pavements. Bituminous pavement is nothing but the flexible footing. See, bituminous pavements means whatever the tar roads we see on the state highways and national highways. Below that road, what is the foundation you are going to see? Soil foundation or not? Yes. So if the foundation is based upon the soil only, then we call it as a flexible footings. And rigid footings, concrete foundation. Or I can give you one more example for this one as whatever the concrete CC pavements would be there or not. CC means what is the CC pavements? So concrete pavements, see cement concrete pavements, those are nothing but CC pavements. Pavement means road. In streets we can see the CC roads are not. Those are comes under as rigid footings. And flexible footings are, see, beneath the bitumen, you know that beneath the bitumen, you can see this is going to be subgrade, subbase, base, and wearing course. This is the road, state highway, and you can observe wearing course, base course, subbase course, subgrade course. That comes under as flexible footings. Now, generally, prefer rigid footings than flexible because flexible footings are very less See, sir, then when do we use the flexible footing, sir? Before concrete technology, which means before 1857, 1857. That was the year the British men has introduced the concrete technology. And before 1857, there is no concrete. Up to that point, the structures were standing on a base which is made up of a soil mass only. Such a type of footings were the flexible footings. Once we introduce the concrete technology, from there onwards, we go for the rigid footings. So right now we introduce means we prefer more of rigid footing than the flexible footing. All BD roads are flexible footings only. Yes. So now this is the way that you are going to find out the immediate settlement. Sometimes in examination, they will give you the I value for the flexible footing, Nana. They will give you the I value for the flexible footing, and they will ask you what is the ultimate immediate settlement under rigid footing. See, when I mention you I value for the flexible footing, then what is the I value for the rigid footing, which is going to be 0.8 times of the I of flexible footing. Now there comes the contact pressure. What is this contact pressure, sir? The contact pressure is a upward pressure exerted by the soil mass on the footing. This is an upward pressure acted by the soil, because see, due to this load, the soil will offer some resistance or not, and that resistance is known as a contact pressure. So pressure exerted by soil underneath the footing pressure exerted by soil underneath the footing, to resist pressure from structure. And this contact pressure distribution can be uniform or non-uniform based on type of footing. See, the pressure exerted by the soil underneath the footing to resist the pressure from the structure is known as a contact pressure. And this contact pressure distribution can be either uniform or non-uniform. It depends upon the type of a footing. So now let's see. As I told you, footing, contact pressure, and settlement. Contact pressure and settlement. So now you see, in the case of the rigid footing, see, I told you CC pavements, right? In the case of the rigid footing, the pressure exerted by the soil is not going to be uniform. It is going to be non-uniform. contact pressure is non-uniform and settlement is going to be uniform. I'll tell you an example, wait for that. And if it is a flexible, the contact pressure is going to be uniform and settlement is going to be non-uniform. Look, what is the meaning of this one, sir? Listen to me. I hope everybody have seen the bituminous pavements. Yes, I told you the bituminous pavements comes under. Comes under flexible footings. Okay. Have you ever observed the bituminous pavements? Can you see when the bituminous pavements means BT roads are going to be having some undulations would be there or not? If you can observe, some failure would be there, some holes would be there in the case of the bituminous roads. And some areas you can see some undulations would be there also. Yes or no? That undulation is nothing but the ground is going to be settled uneven. The settlement is not going to be even. In the case of BT roads, just now you can, if you can go out also. So you can observe mostly the roads of the bituminous roads, the tar roads, due to the lesser grade of bitumen they use, what happens over there is you can see the undulation failure over the bituminous roads. And that failure is due to uneven settlement. Uneven means non-uniform. Whereas in the case of the bitumen roads, see that bitumen is just a layer over the wearing course. Just now I told you, in the case of bitumen roads, below that who will be there? Soil only, na? One grain to other grain, so that distribution is going to be uniform. Note, inflexible footings contact pressure CP, I'm telling you, contact pressure distributes from one grain to another uniformly. So this is the equation of the ultimate immediate settlement. Some of the people are asking, sir, please show the previous slide. See, okay, fine. This I value, I am all about discussing the I value only because this mu depends upon the lateral by longitudinal. So elastic constants these are. Now, if you observe, and in the case of the rigid, you see in rigid contact pressure non-uniform. See, I said you concrete foundation. Now, in the case of the CC pavements, the CC pavements are going to act like a slab. Acts like a slab. When they act like a slab, the entire load will be taken by the slab only. And the soil is going to begin a non-uniform distribution. And in the case of the CC roads, if you observe your street roads, those may be CC roads. If there is a settlement, the entire footing or pavement settles uniformly. The entire footing or settlements uniformly. Uniformly means settlement is going to be same everywhere. You tell me, are you going to construct your structure with a footing which is having uneven settlement or even settlement? Just imagine if your footing has uneven settlement. If this is a footing, if the footing falls like this, do you think the structure is going to be stable? Think. If the footing is this, and if it settles uniformly, then the whole structure will settle uniformly. And if it is going to be settles non-uniform, then such a type of settlement is no. Hope you can remember one example, Leaning Tower of Pisa? Yes or no? That Pisa Tower is there, na? Whatever the Pisa Tower, So I hope you remember the Leaning Tower of Pisa. Pisa Tower is going to be leaned, and whatever the deformation is known as a differential settlement. One footing, one level, other footing, other level. The difference between these two footings is nothing but the differential settlement. So now coming to the distributions. Yes. So, okay, fine. In the case of rigid footing, if this is a footing, and you know this is a soil, so beneath this is nothing but the soil, right? And if this soil if the soil is clay and if the soil is sand, how the contact pressure is going to be distributed, how the settlements are going to be distributed. So before going to this, I want to say one point over here. Please listen to me. A lot of people are focusing on asking a question and sir, we neglect lateral deformations. Are Baba, we neglect lateral deformations in the case of primary consultation, Nana. But immediately we are going to take an initial. This initial means it is going to be very, very less time taking. We don't take the time also. Don't worry about that. Okay. So this is the last topic. Please listen. Listen. Yes. Now, let's imagine you have a heap of soil mass. Let's imagine you have a heap of a soil mass. You please, I'm drawing that also. Let's imagine you have a heap of a soil mass. This is a soil heap. Now you jump from certain height onto this soil heap. When you jump from certain height on the soil heap, now you think, you see there is a soil heap, and now you jump onto the soil heap. I hope everybody in your childhood you might have. Yes. So I hope everybody in your childhood might have done these things. So when you jump on a soil heap, this is a soil heap. When you jump on the soil heap, first what happens? Wherever you jumped, at that point some compression would be takes place or not? Yes or no? Yes. Wherever you jump, at that point some compression would be there, and now that stress will be transferred to the sides or not? So that stress, this is the load. First soil undergoes compression and that stress will transfer to the sides. Just imagine, I'm asking you one point. If the soil heap is a sand, then what happens? Think. If the soil heap is a sand, then if you jump on the sand, then whatever the particles at the corners, they are going to be slide away or not? Yes or no? Yes or no? So when you jump onto the soil mass as a sand, first the sand will undergo compression. Whatever the particles on the sides, see, if I say this is a sand, now if you jump from certain height over here, then wherever you jump, the sand will be compressed and on the sides the particles will be dislodged. I hope you understood this figure. So when you jump on a sand, wherever you jump, there the side, at that compression, it means at that point there is a compression, and the side particles are going to be dislodges. Side soil particles gets dislodge. What is the meaning of dislodge, sir? They will break down, means they are going to be come out of the structure. Sorry, I have broken my bottle. So there is a side particles are going to be dislodges. And now the screen is not visible to you. What about now? What about now? Still it is happening. Please. What about now? This. Okay, maybe. Even this internet is not allowing us to go further, because this internet also getting to know that the time is going to be near to the 1 o'clock. So Mr. Pawan sir, you please shut down the class. It's going to be about 1 o'clock. Even the internet is giving some signs for us. These are the nature signs, which shows that we need to conclude the class. Okay, fine. I hope so. Now my voice is so clear, because I want to do one thing. So with this, I will be concluding. Yes. So now I'll be concluding this topic. Then is not going to be much. So if you understand this point, that's going to be completed. So you please look over this one. Yes. See, in the case of the sand, listen please. I hope you can see the figure. So see, in the contact pressure, I'm just giving a repeater. As the contact pressure is exerted by the soil under the footing. So if it is a footing, a rigid footing, contact pressure is going to be non-uniform. In flexible footing, contact pressure distributes from one grain to another grain uniformly. So in flexible, the distribution is going to be uniform. Now, let's see how this is going to be distributed over here. So now, let's again, I'm going to take this one now. Listen, please. If this is a heap of soil, this is soil heap. Let's take this heap as sand. See, if it is a sand, now, if it is a sand, if you jump from certain height, you are here. If you jump from a certain height, now what happens when you jump on a sand heap? I hope you have done this one in your childhood also. So when you jump on the sand heap, now this sand heap, so now you will be here. Now you will be here, and this sand heap will undergo compression over here, and whatever the particles on the sides, they will get dislodges on the corners. Yes or no? On the corners, the particles will get dislodges in the case of the sand. In sand, the corner sand particles will get dislodge. Will gets dislodged. So what is the meaning of dislodge, sir? Fails. So which means in the case of the sand, the side particles or corner particles will get dislodged, which means on the sides the pressure exerted by the soil will be less in the case of the sands. So I can say in sands at the corners the contact pressure. What is the meaning of contact pressure? You know the contact pressure. What is the meaning of contact pressure? Underneath the footing. Pressure exerted by the soil mass underneath the footing. So in sands at the corners, the contact pressure will be very less and particles will dislodge compared to center. Compared to center. Now, in the case of if it is a clay heap, if it is going to be a clay heap, this is a clay heap, Nana. In the case of the clay heap, so now let's take again, you are here, you are jumping. When you jump on the clay heap, now when you jump on the clay heap, now you see here the soil will undergo some compression. Here the soil will undergo compression, but the side particles does not dislodges anywhere. The side particles will not dislodges anywhere. See, this is the initial heap of the soil mass. This is the final heap. Now the corner particles are stable due to cohesion. So due to cohesion. So in the case of the clay, from this I can write, in clays due to presence, or I can write over here, the strength of particles is less and particles will dislodge due to presence of cohesion. Strength is more at edges or corners, and particles won't dislodge. So now you see I have explained in sand and in the case of the clay. Now let's see what is going to be seen in a sand and clay. So what I said you is, if the soil is going to be, if this is a soil mass, now if the footing okay, if the soil is clay and if the soil is sand, what happens? Now if you have understood this one, you please tell me. So in the case of the rigid footing, which pressure is going to be uniform? You please observe. I told you in the case of the rigid, which is going to be uniform, settlement is going to be uniform. Yes. So if it is a footing, the footing will undergo settlement. Yes or no? Does the settlement is a downward direction or upward direction? Settlement is going to be a downward direction, because when the footing undergoes settlement, it moves downward. Yes. So in the case of rigid footing, whether it is going to be clay or sand, if it is a rigid footing, then the contact pressure is going to be uniform. Then the settlement is going to be uniform. Whether it is a clay or whether it is a sand, the settlements are going to be uniform. What I am representing you here is, you observe, this is the base of footing, Nana. This is the base of footing. So beneath this, the settlements is going to be uniform everywhere. So whatever this representation is nothing but the settlement. But now there comes the contact pressure distribution. I'll see how many of you will understand this one. And in the case of the contact pressure distribution, just now I say, if it is a clay, due to presence of cohesion, strength is more at edges or corners and particles won't dislodge. Arey Baba, if the strength is more, then the resistance offered by the soil. What is meant by contact pressure? Pressure exerted by soil under the footing. So now you see, what are these points? These points are going to be the corner points or not? Mind it, this is the base of footing. This is the base of footing. So these are going to be the edges or not? These are the edges or corners. So now I am representing the edges or corners. So from this I can say, you observe, in the case of the clays, due to presence of cohesion, strength is more at the edges. Then here, strength is more at the edges. So where the strength is going to be more? Strength is more at the edges compared to the center. The strength is more at the edges, because due to presence of the cohesion. And now the strength is going to be less at the center compared to the earlier condition. See, this is known as contact pressure distribution, and the distribution is going to be a concave upwards or convex upwards. This is a distribution which is known as convex upwards, So this is known as the contact of pressure. So in the case of clays, contact pressure is more at edges and less at center. This is what I want to say at the end. Now similarly, can you please tell me what happens in the case of the sands? So in the case of the sands, you see, in sands, at a corner the strength of the particles is less. At a corner the strength of the particles is going to be less. When the strength is going to be less, here the contact pressure will be less at the sides or corners, and the contact pressure is going to be more at the center. So now you simply join these points. This is the contact pressure, which is going to be convex downward. And whatever the representation, keep in your mind, always the contact pressure is upward direction and settlement is the downward direction. You please remember that. So always the contact pressure is going to be upward direction and settlement is going to be always downward direction. So now if you observe, in the case of the sand, contact pressure is less at edges and more at center. So I told you now, repeating again, if it is a rigid footing, settlements are going to be uniform. Yes. If it is a rigid footing, settlements are going to be uniform. And if it is the contact pressure is going to be non-uniform. As the contact pressure is non-uniform, in the case of clays, this is the value. And in the case of the sands, this is the value. And this is the one which is very, very important for the GATE and IES. After all, out of this, what I want to say here is, if it is a clay, it has more strength at the edges. More the strength, more the contact pressure in rigid. And less in the case of the sand, strength is going to be less. Lesser the strength, lesser the contact pressure. Now simply you apply the same thing in the case of the flexible. If it is a flexible, now if you understand this one now, within a minute we can conclude everything. Now here, this is going to be the soil. Again, if the soil is going to be clay and if the soil is going to be sand, this time, if this is a flexible footing, now in the case of the flexible footing, which is going to be uniform, in the case of the flexible footing, see, contact pressure is going to be uniform. Contact pressure is going to be uniform. So now this is a contact pressure. You see here the contact pressure, and you know this is nothing but the base of the footing. This is nothing but the base of the footing. So as it is going to be base of the footing, now you can say here the contact pressure is going to be uniform. The contact pressure means upward. See, when I say the upward distribution, and this is going to be the contact pressure. So in the case of the flexible footing, the contact pressure is going to be uniform. Now let's come to the settlement. Again, I know only one point. The point is, in the case of clay, strength is more at the corners. In the case of the sand, strength is less at the corners. Okay, I see the corners. When you see the corners, in the case of the clay, at the corners, strength is going to be more. You tell me, if the strength is more, does the settlement is less or more? More. So in the case of the clay, at the corners, due to cohesion, strength is more. When the strength is more, then does the soil undergoes more settlement or less settlement? Less settlement. So in the case of clays, now the settlement will be less at the edges and more at the center. Now you observe, I am representing the direction downward. What is the downward direction represents? Settlement. Now if I join all these things, this is going to be the settlement. So I can write in place for flexible footing, settlement is more at center than corners. Why, sir? Because, sir, only one reason, sir. I told you, sir, in the case, sir, due to presence of cohesion, sir, strength is more at the edges, sir. Strength more, sir, contact pressure more, sir. And if it is a flexible, sir, settlement is going to be less, sir. Similarly, in the case of the sands, at the corners, strength is less. When the strength is less, settlement would be more. At the edges, settlement would be less at the center. Now if you join, this is going to be the settlement and in sands, settlement is more at edges than center. So that's all with this topic, contact pressure distribution and settlement. So what you need to know here is just simple one point. In the case of sand, at edges, strength is less, strength less. So if it is a flexible, contact pressure is going to be less, and if it is a rigid, settlement is going to, if it is a flexible, settlement is going to be more, and if it is a rigid, contact pressure is going to be less. Simple, strength less, resistance, contact pressure less, settlement would be more. That's it. Okay, fine. So that's all with this topic. You please go through the previous gate questions once. I'm not going to say, but I'm just going to show off. That's it. See this geotech. And these questions I have given you in chapter number 10, please. Yes. Lots of things.
Class completed, sir.
Complete అయిపోయింది వీళ్ళు చెప్పేసి సార్ హ్యాస్ గోన్ ఇంటర్నెట్ కనెక్షన్ పోయిందని చెప్పేసి ఓకే ఇది ఎనఫ్ ఈ రోజుకి ఎనఫ్ అని చెప్పు ప్లీజ్ గో త్రూ గేట్ అండ్ ఐఎస్ క్వశ్చన్స్ ఆన్ దిస్ టాపిక్ అని చెప్పాలి మెసేజ్ పెట్టేసి
అలాగే సార్ రైట్
Okay, fine. See, like whatever I have written, it was been done. But let's see the last 1 minute. Please spend me 1 minute because of for you only. I want to discuss this one. Yes, I hope everybody is able to see. Please look over here. This is a contact pressure distribution I have given you, and so they have given some list 1 and list 2. You please look over this list 2. The list 2 says the rigid footings, flexible footing, and cohesive soil and cohesionless soil. What is meant by cohesionless soil? Sand. So now, can you please look over this condition once? First of all, while you are seeing these questions, you have to look whether the direction is upward or downward. Come on, you please look over here. Is it upward or downward? Upward, which means this is definitely a contact pressure. And this is also a contact pressure. And this is also going to be the contact pressure. And this is going to be the contact pressure. 1 minute. Is that question? Yes. You please look over this question number 13, please. This question number 13. The contact pressure distribution under a rigid footing for a cohesionless soil. So I am asking you the contact pressure distribution under a rigid footing for a cohesionless soil. Cohesionless soil means sand. So in the case of sand, you know that at the corners strength is less. When the strength is less, contact pressure is less at the corners or edges. So the contact pressure uniform throughout? No. This is a rigid footing, so it's not going to be formed. Zero at center and maximum at the edges? No. And in the case of the rigid, if it is a cohesionless, at the edges very less. So now zero at the edges and maximum at the center. See, the literal meaning of zero here is, you see, this is the contact pressure distribution. At the edges very less, at the corners more. So the answer is going to be 0 at the edges and the maximum at the center. So the option is going to be correct answer as a C. And you please go through the remaining questions in GATE also I have given. In GATE also you can see, you can observe in chapter number 10. Yes, you see, you can go through, means I am leaving this question number 1 for you because so that you can go for that. But I am explaining only one question. See, you observe here. The figure shows the contact pressure distribution underneath. This is a contact pressure distribution. So contact pressure is going to be non-uniform in the case of what type of footings? Contact pressure is non-uniform in what type of footings? Rigid. So remove the flexible footings first of all. Answer should be either rigid footing on clay or sand. And if you observe below the footing, at the corners, the pressure is more. In what type of soils? At the corners, the contact pressure is more. Clay, because clay has strength. So answer is going to be clay. So this is non-uniform first of all. Non-uniform. When it is a non-uniform, definitely that is going to be a rigid footing and more at edges. More at edges means that is going to be clayey soil mass. The answer is going to be rigid footing on the clay. So you please go through the similarly, you can see these questions also. See, there are a lot of questions asked on that one. Here is also one question. You please go through these questions also. So now, there is one more question. The nature of the contact pressure distribution under a rigid footing on sandy soil. So first of all, rigid footing. Rigid footing means contact pressure is not going to be uniform. Remove this. And coming to the distributed load sandy soil mass, you please observe. Sandy soil mass contact pressure is going to be very less at the edges and maximum maximum at the center. So answer is going to be C. And this is going to be 0. Literally, it is going to be 0. It is not 0. So when they mention, if they given this figure, this is the correct one. Answer is going to be C, because this is a sandy soil mass. Sandy soil has the lesser contact pressure at the edges, more contact pressure at the center. So with this is just these are the things that you can go through also, but I just want to mention all these things. That's it. So that's what I want to say. And with this, I will conclude the session. I am concluding the session. So I hope whatever the discussions we made, you understood. You please go through the notes once again, because I have explained each and every point in detail. So now with that, enough for today. So those who wants to leave, they can leave. The class is completed, class is over, but you have to go to the notes once again. And I am asking you, I need a last slide. If you have taken last slide means for the flexible footing, I lost that, because up to that point I have said everything. Let me check that once again. Yes, I have saved up to the last slide, but I need one more slide from you. Everyone, I have saved up to this point. I need a last slide. Please send it to me to my mail ID. To my mail ID. So you please send that to me to my mail ID. Last slide, that pressure distributions on the flexible footings, you please send it to me as soon as possible, so that I can send it to you by attaching. I lost that slide only. Okay, so with this, I'm concluding the session. Please take care of yourself. Up to that point, bye. So yeah, with this we have completed the chapter. So chapter number 11 is completed, and tomorrow we are going to start chapter number 12, compaction. So fine, please take care of yourself. We'll be seeing you in the next class tomorrow. So please send me that. Please send me that last slide. That's it. And concluding. Bye. Mukesh Ambani, I'll reply to your mail. I'll see that. I'm not using any application. I'm just exporting the images to the PowerPoint, and then I prepare the PDF. I do it on my own. So fine. Okay, bye. Have a nice day.